Hi everyone, welcome back to PW English Medium channel. Friends, I hope you already know that we have started a new batch by the name UMEED NEET English batch, right? So in this batch, we are going to cover almost every chapter in one-shot lectures, right? So in these one-shot lectures, we are going to complete the theory part. We are going to also talk about some numericals, right? So first of all, what is the price of this batch? So this batch is absolutely free. You can watch the videos of this batch. You can watch these classes on our YouTube channel by the name PW English Medium channel, and you can also watch if you don't want the ads to interrupt your study. So you can also watch these classes on PW app. On PW app also it's going to be absolutely free, along with the ad free experience. You can also get the notes from PW app, right? So I'm going to explain how you're going to get the notes, what those notes are going to be about. We are going to talk about it. But first of all, hopefully you already know my name. My name is Subrat Sharma. I teach in Yaqeen English batch. In today's class, we are going to talk about basic maths and calculus, right? So I think this is one of those topics which is important for everyone. So I was going to say that which are the students who should watch this lecture. So I think everyone should watch this. Primarily it is for NEET students, but even if you are in grade 11, grade 12, you are preparing for NEET, you are a dropper, or you are preparing for JEE, right? Or you are just preparing for your boards, this class is going to be for you, right? So no matter if you have just started to study, hopefully not, right? I am hoping that you must know a little bit things about basic maths and calculus by now, but still I am going to start from the scratch. I am going to start from the basics. I am going to complete all the necessary topics for NEET, right? So today's topic is basic maths and calculus. In today's class, we are going to complete these topics. So we are going to start with a basic definition of function. We are going to understand what do we really mean by function, right? Then we are going to talk about trigonometry. So hello trigonometry. I know that for many students they feel a little bit of uncomfort whenever there are trigonometric formulas, or there are manipulations of formula. Let's suppose you have to convert cos 2 theta into you have to convert double angle into a single angle, right? So many students actually face that trouble. So we are going to complete trigonometry in today's class. We are going to give sufficient amount of time to trigonometry. We are going to talk about compound angles and everything else. Then we are going to start calculus. That means we are going to talk about differentiation, integration. You know that this is very important. Then we are going to talk about some standard graphs. The reason that we are going to talk about standard graphs in today's class is that you must be knowing that in many questions what NTA does is they just say that okay, explain which graph, or they say that which graph explains the relation between, let's say, pressure and volume, right? Or between any two quantities in a formula. So for that we must be able to understand the names of the graphs, how those graphs are, how we can draw them. So we are going to talk about some standard graphs. Then these two topics are very simple and very easy, but still in couple of chapters we are going to use the concepts of binomial expansion and AP and GP. So we are going to cover those as well. The last topic is going to be about vector algebra. Again, this is also going to be really important. So these are some of the most important things, that calculus, trigonometry and vector algebra. So please understand, this class is going to be for everyone. No matter you are studying, if you are in grade 11, grade 12, or you are a dropper student, you are going to, this is going to be beneficial for you, right? So that's my guarantee. Now I'm going to start the class. Before starting the class, we are usually doing a thing that we usually tell before starting a lecture. We usually tell what is the weightage of this chapter. So obviously NTA doesn't dictate a particular weightage, but we analyze the weightage by looking at the previous year questions. How many questions have come from a particular chapter in previous years? So what's going to be the weightage for this one? You tell me, what should be the weightage? I think the weightage is actually 100%. Is that correct? Because in almost every chapter we are going to use, let's say, either we are going to use the concepts, basic concepts of function is used everywhere. Trigonometry is going to be used in almost in every chapter somewhere or the other, right? Differentiation integration again is going to be used in almost every chapter. Then standard graphs, I have told you, it might pop up anywhere, right? So what I really want you to understand is that this chapter is actually, it has the most important chapter. It is one of the most important chapter, because if you are not really thorough with these topics, you are going to actually suffer difficulties. You are going to suffer that uncomfortness in almost in every other chapter. So hang on, stay with me for another, let's say another 2 to 2.5 hours. We are going to complete all of these chapters in that amount of time. After that, make your own notes. I'm going to also along with the class, I'm going to also give you a couple of questions to solve, right? So after solving it, write down your answers in the comments section. And I'm going to also explain how you can actually take out the notes from here, right? So let's start with functions. What do we really mean by functions, right? So the basic definition, the most basic definition, what I can say in layman terms is, a function is like it's like a machine, a mathematical virtual machine, right? Obviously it's not a real machine, it's a mathematical machine, or we can also call it as it's like a rule, in which if we are going to plug in some inputs, then according to this rule, now this rule can be anything, my friends, it's going to give certain outputs. So the relationship between the input and output is actually the rule. So I have started the class, and I really want you to actually complete all of these topics with me. So sit down, take out your notebook, take out your pen, let's start study. And even if you know what function is, hang on, I really want you to actually sharp your concepts, right? And you might not actually feel that, okay, function is not really important, I am a NEET student, why I really have to study function? But it is actually important. We are not going to actually talk about the topics which are the part of the class 11th or 12th maths subject, right? We are going to talk about only those topics which are necessary for us. So trust me, we are not wasting our time. We should study all of these things. So once again, what is a function? Function is actually a type of a rule which actually relates an inputs and an output. We can also actually define function as it is a relationship between a dependent variable, and an independent variable. So you must be knowing what variables are. And dependent and independent terms are also self-explanatory. Dependent variable means that the value of these variables are going to depend on something else, right? Independent means it is not going to depend. So for example, let's take an example that will clear our concepts. Let's suppose I am writing a function something like y equals to x plus 3. This is a function that I have written. So I am going to say that this is my input, or this is my independent variable, right? Sorry, this is my independent variable. I am going to actually assume what x is. So I don't have any dependency on choosing what x is, other than I should actually choose x from its domain. Little bit of things, don't worry, we are going to talk about everything. So what I can choose for x, I can choose it anything. I don't have any problem over here, right? So I can choose x to be anything. Let's suppose that x is actually equals to 1. So 1 plus 3 and y comes out to be 4. Very simple equation, right? Equation of a straight line. So this is your independent variable, this is your dependent variable, y depends on x, right? X is called as independent variable, y is called as dependent variable. For x, we are going to talk about, this is what input means, right? So this is what input basically means. Now the thing is, what do we really mean by domain and what do we really mean by range? All the possible values, that you can take for inputs is known as domain. So this is for that particular example, I am going to write this is all the possible values for x. Now what do we really mean by this? What do we really mean by all the possible values? Is there anything which is not possible? Yes, there is. Like for example, let's take another example. Let's say we are looking at a function something like this. Hopefully you can see this. Y equals to 1 upon x plus 1. This is one of the function. Now I can't take one of the values of x, and that is I can't take x equals to -1. Why? Because if I will take x equals to -1, what's going to happen is this will become 0, and this is something that we call as it is a not defined term, right? This is an absurd situation in mathematics, so we are going to actually avoid this scenario. So we are going to say that the domain for this one is going to be, you can substitute x anything that is all real number except just don't put -1. Just don't put -1. So the domain is all real number except -1. That's it. That's all you need to know. The reason that you need to know is that you are going to play with these formulas, right? You are going to play with function. You might not know, but you are going to play with it, right? For example, if you are going to talk about physics, now many of you are going to you must be thinking, okay, now please tell us where in physics we are going to use this. Just take any other formula from physics. Let's say you are talking about the formula of potential from grade 12th, right? Or from grade 11th, you can take the formula for gravitational force. So for gravitational force, the formula is something like this: G m1 m2 upon r square. So this is also a function, right? This is also a function. I'm going to we all know that G is constant, m1 and m2, let's say they are constant. That means f is actually a dependent variable and it depends on the value of r. So we can put anything on r, we are going to get what f is, but what we can't put on r is, we can't put r to be 0, right? Or let's suppose this thing is written as something like this: r plus 1 whole square. We can write it anything, right? I'll write it as x plus 1 whole square. Now what is not a permissible value for x? -1 is not permissible. So what I really want you to know is that we must go for domain whenever we have got formulas like this, right? So this is a function. Function basically it's a relationship between a dependent variable and an independent variable, and the relationship is actually governed by a rule. This is what the rule means, that you must add 3 to the dependent variable, so to the independent variable, so to get the dependent variable. That's what the rule is. With this, I think now we can move to our next topics. Now we are going to talk about like trigonometric functions, right? Now before moving to trigonometric functions, hang on, let's also define how we write functions. So functions are written something like this. Let's suppose you have got f of x. This is read as, this is function of x, which means x is the independent variable. Sometimes we can also write this thing as, if the dependent variable is y, we can also write it as y. So this is same thing, right? So if you want to write y or if you want to write f of x, these are the same things, right? And then you can put whatever the rule is. Are you getting it? So initially the rule was like x plus 3, x plus 1, anything what the rule is. So this is how we write f of x. Now you tell me, is this really that number x? Can I do something like this? So let's suppose I've got f of x divided by x. Let's just suppose. So can I cancel out these things? Absolutely no. Na? It would be really silly to do something like this. This is nothing but this is just a representation of function. This is a way of writing a function. I really can't cancel these things, isn't it? Why we are talking about this thing? Because sometimes you guys are very sweet, very innocent. What you do is, when you come across trigonometric functions, sometimes you do things like this. So hopefully 95% of you might not be doing it, but for any percentage of students who have a little bit of doubt in these things, please understand that what do we really mean by function. When we are going to talk about trigonometric function, this is going to be really important, that we are going to actually respect whatever the angle is, right? That angle is input. That's what I'm trying to say. Let's come back to our topic of trigonometric functions. So you must be knowing it, what trigonometric functions are. Trigonometric functions are nothing but these are the ratios of a right angled triangle. So if you have got a right angled triangle over here, and we have got, let's say this is the theta. So the opposite side of this theta is going to be the perpendicular. This is going to be base or adjacent, or this is going to be hypotenuse, right? So we know the basic three trigonometric function like sine theta. So sine theta is the ratio of perpendicular to hypotenuse. Cos theta is the ratio of base to hypotenuse. Tan theta is the ratio of perpendicular to base. So what I'm trying to say is that then when we are going to, and of course the other three as well, right, like sec, cot and cosec, right, those as well. When we are talking about this sine and theta, please try to understand that this theta is the input, and whatever you are going to get out from this, whatever the number that you are going to get out from this is going to be called as the output. Alright, so this is very important, that this theta is actually the input, and the answer that we are going to get out of it is going to be an output. Now this input right now is an angle, right? This input is actually an angle. Why not let's just start by defining what angle is. So now this is really important. The function, we have got a function, we can also call it as a mathematical formula sometimes. That function is, inside that function you must be able to define each and every term. Even if it looks pretty simple, that okay sir, this is actually quite simple to define. This is angle, right? So we know what angle is, but can you really define it? Angle can be actually defined by, it can be defined as, let's suppose that we have got a line over here. So angle can be defined as the degree by which we can actually rotate it, the amount of rotation, or it can be called as the amount of rotation. So let's suppose the amount of rotation is something like this. Now we don't know what to call it, so let's call it as a variable as theta, right? So this is the amount of rotation. Now how we are going to actually define it? So what we are going to do is, we are going to say, okay, so let's say this is an arc. Let's find out the arc length. Let's say the arc length of this arc is actually S, and the radius of this arc is R. Done. So theta will be defined as, the angle will be defined as arc length divided by the radius. This is the formula for angle. Now please try to understand. That's what I said, we are going to go from the very basics. When we are going to talk about theta, it will have no dimensions. Why? Because arc length will be measured in length, it will be measured in, the SI unit is going to be meter, the radius SI unit is going to be meter. So this is a dimensionless quantity. Got it? But we are going to talk about its units. The units are going to be, we are going to actually measure it, not unit, we are going to measure it in radians and in degree. So that we have got like two things, and obviously you might be knowing this. So those two things are going to be radians and degree. What are those things? Let's suppose that we are talking about a complete circle. We are talking about a complete circle with radius r, So I'm going to write something like theta equals to, what is the total arc length? So you are going to say, sir, now the total arc length is going to be nothing but the circumference. So circumference of a circle is actually 2 pi r divided by r, that is the radius. So the angle that is coming out to be is actually 2 pi, and you are going to say, sir, now I really don't know if I assume that you have just started in grade 11th, or you are just going to start in grade 11th next year. You are going to say, sir, I really don't know what this 2 pi is, but I know this, that this angle is actually 360 degree. Right? So this means that this 2 pi basically corresponds to, or I can also write it as 360 degree. So this is in radians, and the another thing is obviously in degree. Right? So you can always convert them from radian to degree. So this means that 2 pi radian basically means 360 degree, which means 1 radian would be 180 by pi degree. Right? Which means if I want to convert theta radians into degree, so I'll actually multiply 180 by pi with theta. Is that correct? Right? So it's quite easy thing, and what the value of pi is nothing but 3.14, right? Same thing. So this is what the angle conversion is. So 1 degree is actually, or you can also convert it. I said that 1 radian is actually equals to 180 by pi. So 1 degree will be equals to pi by 180. So pi by 180, if you are going to convert, if you are going to write 3.14, so it's going to be approximately around 0.02 radian. Quite easy, right? Very easy stuff. Or 180 by pi is nothing but 57 degree. So this is also really important to understand. So degrees to radian formula, radian to degree formula, very easy. You can just play with this formula. Like for example, as if you want to convert, like you have got certain thetas over here. You have got like 0 degree, you have got 30 degree, then you have got like 45 degree. The known angles, you can also find out the unknown angles. So for 0 degree, it's going to be 0 radians, right? For 30 degree, what we are going to do, we are going to write pi by 180 into 30. So this is going to be actually pi by 6. Similarly, this is going to be pi by 4. Now you can just find out any value. So it's not of a big deal, right? If somebody says that find out the value of angle of 3 pi by 2. So just multiply 3 pi by 2 by 180 by pi. So this is going to be, is that correct? So this is going to be 270 degree. Very basics of trigonometry, right? Shall we start? Can we move on? We have that's why we started with functions. Now we know that theta is actually the input. We have also defined what theta is. Now we have also written what those sine, cos, tan basically means. Those are nothing but functions. Functions of what? You can define those functions as, like you're going to ask me, sir, what the rule is? The rule is those are ratios of sides of a right angle triangle. Sine theta is ratio of perpendicular to hypotenuse. This is what the rule means, right? Moving on. Now we are going to talk about measurement of positive and negative angles. Basically measurement of angles. This is very important. Why? Because from here we are going to actually find out how to measure angles. So let's suppose we have got a line, something like this. We have got a line and we want to measure the angle. First of all, we always measure the angle from we always measure angle from positive x-axis. Now in two ways. If you are doing it in anti-clockwise direction, this angle will be will be written with a positive sign, right? So anti-clockwise, if we are measuring from anti-clockwise, it's going to be positive angle. It's going to be written with a positive sign. If it's if we are measuring it in clockwise direction, we are going to put a negative sign, right? So this, whatever this angle is, let's suppose that this is 30 degree, this is 90 degree, so this is going to be 120 degree. Hopefully you are getting it, right? So this first quadrant is 90, this is 30 degree, this much of angle, so this is plus 120 degree. So I'm just going to write plus 120 over here. Got it? Done? What this angle is going to be? If you're going to talk about the magnitude of this angle, the magnitude of this angle is going to be 360 minus 120. But we are not going to write it with a positive sign, we are going to write it with a negative sign. Or what you can do is, this is 180, this was 30, this is 60, so this is going to be minus 240 degree. Why minus 240? Because we are measuring it from a clockwise direction. That's it. No big difference, right? So this is pretty simple. We always measure angles from positive x-axis in anti-clockwise direction, then we write it with a positive sign. If not, then we write it with a negative sign. That's it. Moving on to different trigonometric ratios, and we have already discussed the trigonometric ratios. Those trigonometric ratios were the sin theta, cos theta, tan theta, and we have got certain values for these. Like for example, as if I am going to talk about like sin 0. Right now I am talking in degree. Sin 0, if I am talking about like sin 90, what does we really mean by this? Let's try to understand. So we have discussed that this is nothing but this is a right angle triangle, something like this, and this is the angle theta. So now you are going to say me that okay, now you mean that this theta should be 0. So if this theta should be 0, it means that we have got a base something like this, and we have got a perpendicular something like this, and this is what the hypotenuse is. Now if you are saying that this should be actually 0, then it will be 0 when this line will lie something like this. Is that correct? Right? And when this line will lie something like this, there will be no perpendicular. So perpendicular will become 0, and hence sin 0 is nothing but 0. So 0 upon hypotenuse, whatever that is, we don't have to worry about, because this will become 0. Is that correct? So with this, by this logic, we are going to actually define, not by logic, but we are going to write the answers for all the angles. You must be knowing about all of these things. So for sin 90, we know that sin 90, what do you mean by sin 90? That this angle will increase up to 90 degree. So if it will increase up to 90 degree, it will be something like this, and this will be then exactly equals to the hypotenuse. So in that case, this will become 1. So you need to remember all the other formulas for the degrees, like 30 degree sine is 1 by 2, 37 3 by 5, 45 1 by root 2, 53. I mean, this is quite pretty simple, right? So if you are still struggling with this thing, the first thing that you need to do is you need to actually remember all the formulas. Don't start studying any other chapter if you have a little bit difficulty of remembering, right? Like what if I quickly say what tan 37 is, you must quickly say, okay, this is 3 by 4, right? Or what cot 37 is, that is 4 by 3. What is sin 37? 3 by 5. What is sin 53? That's 4 by 5. It should come with this speed. If it is not coming with this speed, don't start with another chapter, first complete these things, right? So this is very important. You can note it down from here as well. Like after from 90 degree for 120, 135, 180, I'll ask you to actually remember the formulas for 120 degree as well. This is also very, very important. 120 degree, we are going to use 120 degree quite often especially for cos 120. In vectors and all, you must be knowing that in vector we have a formula for addition of two vectors. In that there is a formula for cos theta, right? The square root of a square plus b square plus 2ab cos theta. So many a times the angle between the two vectors is 120. Now I don't want you to actually write the compound angle formula or remember that okay, sine 120 can be written as cos 90 plus 30, or no, I'll do it like cos. You don't have time for all of these things, right? A student who's going to actually score really good marks in NEET, he or she will must remember that what cos 120 is, right? So this is again very important. Before going to the another topic, let me stay to the graph of sin x, because I really want you to know these topics from every corner. This is the graph of sin x. It starts from 0, right? It starts from 0. If you can see the values of this sin x, actually it oscillates between two values, that is +1 and -1. What does it mean? If I am going to talk about sin x now, the range of sin x is going to be, from -1 to 1. This is what range basically means, right? So if you have got, why this is very important, if you have got a function like this, tell me what is the maximum and minimum value for this function. Take your time, pause this video, think about it. What is the maximum and minimum value of this function? So hopefully you have paused the video. Now let me explain it and now you check. 4 is a constant. I don't have any problem with 4, right? 4 is constant. Nothing will happen to it. This sin x will have minimum value of -1 and maximum value of +1, right? Which means if I want y to have maximum value, sine must have maximum value, because we have got an addition sign between them, right? So this will be 4 plus, what is the maximum value of sine? So this is going to be 5. And now you know the drill. The minimum value of y will achieve when there is a minimum value of sine, that is -1. So you must know the range of simple trigonometric functions. The range is actually from -1 to 1. And what is the domain? So the domain is actually all real number. How do I know that? Can you please see what this x is? It is all the way from -infinity is going to +infinity, and we are just plotting another values on if we have got like different values between 1 and -1, but we can really take any value on x. So that's what I'm saying, that the domain is all real number. Now what I'll do is I'll actually take a line something like this. Let's suppose I have taken a line and I have drawn it till 2 pi. Why I have drawn it till 2 pi? Well, let me also draw it after 2 pi. But we'll focus it till this point. Why? Because this is actually the 360 degree mark. This is the 360 degree mark. Right? Now please try to understand. Let's suppose that this value is, I am just supposing that it is coming in between of 1 and 0. So let's say that this is 1 by 2. Let's say this is 1 by 2. Right? What are you seeing? We are getting 1 by 2 at this particular angle. What particular angle, sir? At this particular angle we are getting 1 by 2. Hopefully you can see it. right? We are getting 1 by 2 again at this angle also. Is that correct? Then again we are getting 1 by 2 at this angle, which is actually after 2 pi, so I don't have to worry about it. Are you getting it, friends? So it means that if I already know what this value is. This angle is this, if this is 1 by 2, this angle is actually 30 degree. Alright. So what this angle is going to be? We are going to talk about it in compound formulas also, but I remember what I said. I want you to actually know all of these concepts from every other corner. This diagram looks pretty symmetrical. This is 180 degree. This angle is 180 degree. This was 0 degree. So the separation between these 2 points is exactly equals to the separation between these 2 points. Is that correct? So the separation is 30 degree. So this separation is also going to be 30 degree, which means that this angle is going to be 180 minus 30 degree, which is 150 degree. So that's how you can find out the values. So now if I am going to tell you, if I am going to ask you that, okay, let's say sine theta is actually equals to 1 by 2. What is the value of theta? What is theta? So please just don't say 30. First ask, sir, from which range, for which range of values you want me to give the answer for theta. So if I'll ask between 0 to 90, so you're going to say, sir, it's just 30. If I'll say between 0 to 180, you're going to say, sir, it's 30 and sir, it's 150. If I'll say between 0 to 360, you're going to say, sir, answer remains same, because after 360, we'll get the answer, we'll get the same answer at somewhere over here. Can we know what that angle is? 360 plus 30, that is 390. What this is? This value is 3 pi. So this angle will be 3 pi minus pi by 6. So that's how you can find out any theta, right? But still, this is also a little bit of time taking. What I want you to do is, I want you to have a little bit of we have like muscle memory, right? So you have to have these memories for these formula. Like if somebody tells sine 150 degree, I really don't want you to think. I really want you have got an instinct. You must intuitively know that, okay, sine 150 is actually 1 by 2. And it will happen with lots of practice. Without practice, it will not happen. I'm not saying you to mug it up. I'm saying that you must do a lot of practice, insane amount of practice, that you must remember all of these things intuitively, right? So with this, now let's move. We have got another graph, something like this, and the graph is of cos x. Same thing will happen over here, so now I'm not going to repeat it. It will just consume time. This is for you. Play with this, right? This is a very good book, Play with Graphs, so play with this one. Now let's move to another thing, that is, before moving, let me also talk about one more thing, and I'll talk that thing using the cos graph. That is, if you're going to look at this graph, can you please tell me which portion of graph is positive and which portion of graph is negative? You will say, obviously, sir, that was quite an easy question. The portion of graph which is positive is above x-axis, and which is below the portion of graph which is below x-axis, that will be negative. So it means that between 0 to pi by 2, cos is positive. Is that correct? So between 0 to pi by 2, graph is cos x is positive. I am talking about cos x. And this is the angle, my friends. Right? Again, from pi by 2 to 3 pi by 2. 3 pi by 2, if you remember, it was 270 degree. Pi by 2 to 3 pi by 2, and please mind, I'm not writing this as a minus. I am saying this is a range from 0 to pi by 2, from pi by 2 to 3 pi by 2, the graph is actually negative. Again, from 3 pi by 2 to 5 pi by 2, but usually what we do, we usually talk about a cycle, right? So 3 pi by 2 to 2 pi, the graph is again positive. All right, you got it? Similarly, we are going to actually, whatever I have told you now, we are going to actually write that, we are going to actually write all of those things in this rule. This is ASTC rule. Sometimes you actually call it as after school to college or anything, any jingle you want to create it, right? See, what do we really mean by this? We have got 4 quadrants over here. This thing is 0 radian. This can be called as 0 radian or 2 pi radian, right? This is going to be pi by 2 radian or 90 degree. This is going to be pi radian. This is going to be 3 pi by 2 radian. And that's why when we are going to come back to this, that will be 2 pi radian. So this is the first quadrant from 0 degree to pi by 2 radian, right? So from 0 degree to pi by 2 radian, if you look at sine theta graph, that was also positive. From 0 to pi by 2, sine theta was positive. You are going to say, sir, it is also positive till pi. Let's just talk about the first quadrant. From 0 to pi by 2, sine theta is positive, right? So sine theta is positive. That means sine, we can write it here as sine theta. Then cos was also positive, if you remember. So I'll also write cos. If you'll see for tan, tan will also be positive. So if these 3 are positive, their reciprocals are also going to be positive. That is cosec, sec and cot. That means every trigonometric ratio is positive over here. So that's why we write it as all. That means all trigonometric functions are positive between 0 to pi by 2 radian. Then after this, only sine and cosec is positive. After this, only tan and cot is positive. And last, only cos or sec is positive. So that basically means that is the jingle that I said, after school to college or ASTC rule. This is what it means. Very simple thing, but we are going to use it at multiple places. So pay attention, right? So after this, after the ASTC rule, now if somebody tells you that we are drawing an angle, something like this. Let's suppose that we have got a line somewhat like this, and this is the angle. This is theta. Write down the signs of theta. So sine theta will be negative, right? Cos theta will be negative. Whatever the value is, tan theta will be positive. That's all, right? So now let's move to some trigonometric identities, right? Very important, and please note it down, paste it on your study table, whatever you want to do, but you must remember these things. At least these first 7 trigonometric identities are very important. The first 3 are quite simple. Sine square theta plus cos square theta is equals to 1. Nothing, it's written nothing but sine theta is, you know what it is, right? Perpendicular upon hypotenuse, base upon hypotenuse. Square them, add them, you're going to get square of hypotenuse divided by square of hypotenuse, right? So that's going to be 1. Divide both the sides by cos square theta, you are going to get the second one. Divide the first equation by sine square theta, you are going to get the third one. So the first 3 are the most simple. After the first 3, for the next one, I would like you to look at these ones. Sine A plus, sine of A plus minus B, cos of A plus minus B. Let's first look at them, then we can derive the 4th one and the 5th one. This is sine A cos B plus minus cos A sine B, right? Although you are not going to use them directly, but for safety, let's suppose that God forbid you forgot how to write sine 2 theta, cos 2 theta. You have got a safety net over here, right? So please remember these things. Using this, we can actually find out what sine 2 theta is going to be. So if let's suppose we have got like sine 2 theta over here. Sine 2 theta is nothing but sine theta plus theta. So this is going to be sine theta cos theta plus cos theta sin theta, which means this can be written as 2 sin theta cos theta, right? But please remember, it is absolutely not at all advisable that you are going to do all of these things in your exam, right? You must remember all of these things. We are going to actually use, mostly we are going to use this formula. So this is very important. Please remember this. This is going to be very, very important. Cos 2 theta. We are going to use it quite often, right? And the another, some other variations of cos 2 theta, I am going to write it for you. So you can see cos 2 theta can be written as 2 cos square theta minus 1 using the seventh identity. Please do it by yourself, how we are going to do it, right? You just have to substitute theta, theta, cos theta, sin theta, cos square theta minus sin square theta. Now either you can convert cos into sin, so you will get this, or you will convert sin into cos, so you will get this. How? Using the first identity. Not going to do it, it's very simple. What's important over here is you can convert the cos square theta into the double angle property. How you are going to do it? Please remember that you have got 2 cos square theta minus 1 is equals to cos 2 theta. Is that correct? Right? So using this property, using this identity, we are going to say cos square theta can be written as cos 2 theta plus 1 divided by 2. This is what I mean, right? You are going to use it in multiple places. Like for example, if somebody tells you to integrate cos square theta. Now we have got, we don't remember the integration of cos square theta as a formula. We know integration of cos is minus, is sine, not minus. Integration of cos is sine. Is that correct? But what is integration of cos square theta? So first we are going to convert cos square theta into something like this, then we are going to integrate it. Are you getting it, my friends? Similarly, if you are going to write 1 minus 2 sin square theta equals to cos 2 theta. So using this identity, we are going to say that sin square theta can be written as 1 minus cos 2 theta upon 2. So if you want to integrate sin square theta, or not just integrate, if you want to convert the square, the sin square or cos square into the double angle, right? So you can do it something like this, right, my friends? So hopefully you have got it. How we are going to use these identities. These are very, very important. The next set of identities are not that important, but it is compulsory for you to remember it. See, this is what it's going to make a difference. I mean, most probably the next year NEET paper is going to be slightly difficult with whatever has happened this year, right? Whatever unfortunate things happened this year, most probably NTA will actually, and it should actually increase the level of the paper. And how it will increase it? Now, everyone knows these formulas. So what else you are doing it without impacting a lot of time on your studies? What you can do is you can also remember the formulas of sin C plus sin D. It won't take much of time. Sin C plus sin D is 2 times of sin C plus D divided by 2. Now please don't cancel these 2's. Remember na, we have to respect what function is. 2 sin of C plus D upon 2 times cos C minus D upon 2. You don't have to worry about derivation. I mean, I really don't want you to waste your time on this. Just remember these formulas. Although if you are going to expand this, you are going to get sin C plus D, right? Similarly, sin C minus D. Now, it is actually a little bit confusing that, okay, sin C plus D, sin C plus D, sin cos C minus D, fair enough. Sin C minus D is 2 sin C minus D cos C plus D. The difficulty that you are going to face is when you are going to remember these formulas with cos. What will happen with cos? Cos C plus cos D is 2 cos C plus D upon 2 cos C minus D upon 2. Cos C minus D is 2 sin D minus C upon 2 sin C plus D upon 2. So this is where you're going to actually face a little bit of difficulty. That's what I'm saying. From the very start, please try to remember these things. If you are going to assume that, okay, on 38th May, you have got 38th May next year, you have got your NEET exam, and you are remembering these formulas on the night of 29th, you'll not be able to you'll not be able to use these formulas, right? It is not possible. So it is very important, start it now. These twos are very simple. You must have done this in grade 10th. So there's nothing to worry about the tan A plus B formula, right? Still, I have written it for you because it is important. You must mention these things in your notes. Now moving on, we were talking about the higher angles. Let's go through some notes. Trigonometric functions of angle 2n pi plus theta, where n is 0, 1, 2, 3 will remain same. That's a very easy thing. If you have got something like this, my friends, you remember we were talking about a Cartesian plane, something like this, right? Let's suppose you have got a straight line, something like this. Done? And the angle that we are talking about over here is 30 degree. Now this is 30 degree. So sine 30 degree will be 1 by 2. Absolutely. Cos 30 degree will be root 3 by 2. But if you are going to do one thing, if you are going to do something like this, what we have done? We have completed a rotation. That means now we have done sine 360 degree or 2 pi plus 30 degree. So it will make no difference. Still you are landing to the same thing. Still sine 360 plus 30, that is 390, will remain 1 by 2. So this happens with all the other trigonometric functions, right? So for all the other trigonometric function means sine, and this is just not for 360, like n multiples of 2 pi. So 2n pi plus theta will be, here we should write sine theta. Cos 2n pi plus theta will be written as cos theta. Tan 2n pi plus theta will be written as theta. This is also something you must remember, that for cos and tan, sorry, for sine and cos, for sine theta, the period is 2 pi. What do you mean by period, my friends? Period basically means after which interval the values will start repeating themselves. So after 2 pi, it will start repeating. For cos also it is 2 pi. For tan it is pi. For tan it starts repeating the value after 180 degree. So this is important, right? Moving on. The next point is trigonometric function of angle n pi by 2 plus theta will remain same if n is even and sign of trigonometric function will be according to the ASTC rule. I'll break it down for you. This is actually very easy. What we are trying to say is, let's suppose that we have got a function, right? So function basically means it could be sine, tan, cos, anything. So for function I'm drawing something like this. So this could be sine, cos or tan or reciprocal of this, and then we have got theta, sorry, sine, cos or tan, and we have got theta over here, right? So in this blank place I've got function equals to, and instead of this theta, how I'm going to write it? I'm going to write it as n pi by 2 plus theta equals to, now what they are trying to say is, listen, they are saying that if n is even, what do you mean by even? If n is even, that means let's suppose n is 2. So if n is 2, what will happen? This function will remain same. So whatever this function was, if it was sine, it will be sine. If it was cos, this will be cos. If it was tan, it will be tan. Have you got it? So this function will remain same. What angle are we going to put it over here? We are going to put this theta over here. So you have got, see, you have got two things. First, you have to know what function it will become. Second, what sign is going to be. So function is same and sign will be given by ASTC rule. Now what is this ASTC rule? It means that, now I will give you an example. Let's take an example. Let's suppose we have got sine let's say we have got sine 2 times of pi by 2 minus 30 degree. I'm writing one part in radian, one part in degree. You don't have to worry about, right? This is it. And there is no difference of this whether it is a plus or negative sign. You don't have to worry about, right? I mean, there will be no change in the output sign. There will be no change, right? What this angle is, you can figure out what this angle is. This is written nothing but, if somebody asks you what is sine, this is actually 180. What is sine 150? That's all what I am trying to ask. Is that correct now? Right? So sine 150 can be written as 2 times of pi by 2 minus 30 degree. Absolutely correct. Now you are going to say, okay sir, this means that this is even, this thing is even. So if this thing is even, this will remain same on the other side. So this will be sine, and this is angle 30 degree. So this is going to be 30 degree, right? What is the angle that they are talking about? They are talking about basically 150 degree. 150 degree lies on the first quadrant, isn't it? This is where the 150 degree is going to lie. In this quadrant, sign is positive. So we are going to put a positive sign over here. So finally the answer is going to be plus 1 by 2. That's it. Got it? So it's not that difficult. Easy things. If this n is even, whatever this function is, it will remain same. If it was cos, it would have remained same, right? If somebody asks you what is cos 150, so 150 will be written as 2 times of pi by 2 minus 30. So cos will remain same, so that means cos 30, but in this quadrant cos is negative. So I'll put a negative sign. That means minus root 3 by 2. That's it. Right? Done, my friends. Hopefully everything's clear. You can also check this using the another formulas, like for example as for sine 150, you can check it using 90 plus, you can check it for 90 plus 60. Is that correct? 90 plus 60. So this is going to be sine 90 cos 60 plus cos 90 and sine 60. So cos 90, everything becomes 0, sine 90 is 1, cos 60 is 1 by 2. So 1 by 2 plus 1 by 2. You can also check this one. I'll just check 2 for you, right? After this, you'll have to trust me. You'll have to trust this formula, and we'll keep on finding the answers like this. So for cos 150 also you can do cos 150 is 90 plus 60. You could have also done 180 minus 30 and then apply the a plus b formula. Nothing wrong in that as well. So this is going to be cos 90 cos 60 minus sine 90 sine 60. That's it. Sine 60 is minus root 3 by 2, and you have got a minus sign over there. So this is very, very easy. Now I want you to solve some of the things, right? And I'll be with you. Pause the screen. figure it out by yourself whether you are getting the correct answer or not. What you have to do is you just have to see the sine pi plus theta and check whether you are getting sine plus sine theta or not. See, this is going to be very easy. We have already covered it. We have already covered it. Sine pi plus theta. Just a second. We have got something's wrong over here, right? Sine pi plus theta is plus sine theta. That's correct. The second one is, we don't have to look for the second one. Just a second. Sine pi plus theta is sine theta. That's absolutely correct. For sine 2 pi minus theta, it's going to be minus sine theta, right? So I want you to actually figure it out by yourself, and then we have got some questions on this that we are going to do it. But before that, I'm going to come back to the second rule of this. The second rule is something like this. Trigonometric functions of f 9 pi by 2 plus theta will be changed to the complementary function. What is this co-function? Co-function is complementary function. So complementary function basically means the complementary of sine theta is cos theta. Complementary of tan is cot theta. Alright. So it will change, and the sign of the trigonometric function will be according to the ASTC rule. Same thing. Let's do some problems so that we have a better understanding for this. Let's do some problems from here, right? Like for example, as sine 240. So for sine 240, for the first part, again I want you to pause the screen and do it by yourself, then check the answer. For sine 240, we are going to say it can be written as actually 2 times of pi by 2, that is 180 degree plus 60 degree. Is that absolutely correct? 180 plus 60 is 240. This is even. That means this will remain same sine and this will be 60, and whether this is going to be plus or minus will depend on this angle. 240 degree lies on the third quadrant. In third quadrant, sine is negative. So I'm going to put a negative sign over here. So this is minus root 3 by 2. Please tell me if everything's clear or not. We can do it using another ways also. Right? What could be the another way? If you want to do it, or the next method is, you can write sine. You can also write it as 270, na? 270 minus 30. So 270 will be written as 3 pi by 2 minus 30 degree. Is that correct? Right? Hopefully everything's clear over here. Now please try to understand. This is odd. This is odd. So if this is odd, this will be changed into its complementary function, that is cos. And if it will be changed to its complementary function, cos, and this is 30, we don't have to worry about this sign. You don't have to worry about this sign. The outside sign will be defined by whatever the sign we have got, what we have got for sign at whatever sign that we have got for cos for 240 degrees. So after school 2, so it is also negative. So minus, that means minus root 3 by 2. Is it absolutely clear? Right? So you can use any rule. If it is odd, it will change to complementary function. Sign will be defined by ASTC rule. That's it. Quickly tell me if you have any doubt. Right? Write down in the comment section if you have any doubt. I'll come back and I'll check. Cot 300 will be written as cot 4 pi by 2 minus 60. Is it clear? 4 pi by 2 basically means 360, right? 360 minus 60 is 300. This is even. So even basically means, this is, I'm talking for the second part, for the B part. So this will remain same cot, and this will be 60 degree. And by the way, 300 is in the fourth quadrant, right? So cot will be actually negative. So this is going to be minus 1 by root 3. The correct answer for this one is minus 1 by root 3. I'll not do for the, like I could have also done it like 3 pi by 2 odd plus 30 degree. So that would be tan 30. Tan 30 is 1 by root 3. Tan is also negative in the fourth quadrant. So minus 1 by root 3. Is that clear, my friends? Cos 120 minus 120. Now this is actually something important. Cos is actually, you're going to actually write it down over here. When we are going to talk about functions like cos, so cos for cos of minus 120, this is going to be cos theta. This is an even function, right? So quickly write it down. This is going to be nothing but this is going to be cos minus of 120 will be nothing but cos 120, and this could be written as cos of 90 plus 30, and this is again, please try to understand, this is going to be odd, so this will change sine 30, and this is going to be 1 by 2. Alright, hopefully everything's clear till here. Done? Now let's move. It will change, and it will change to, no, I think we have got a negative sign over here. Yes, minus 120, minus 1 by 2. Absolutely correct. Now what I want to do is I want you to solve for tan minus 60, and I also want you to solve for these 4 problems. So this is your homework. This is going to be your homework. Please remember cos 120 is minus 1 by 2. This is going to be your homework. Very important. Alright, so hopefully you can do all of these things. Just to make it more clear, I am going to again tell you one thing. For example, let's solve again for sine 240. We have already solved for sine 240. The sign that you are going to look for over here is, see, I am going to again explain it. Cos is definitely an even function, nothing wrong in that. The even function basically means cos of minus theta will become cos theta, and if it was sine of minus theta, sine of minus theta becomes minus sine theta. So this is an odd function, right? So this is absolutely correct. The thing that you need to actually remember over here is, we have written it something like this. Cos of minus 120 we have written as cos 120, alright. Then cos 120 can be written as cos of 90 plus 30. So because it is odd, it will become sine 30, but sine will be written because of this function, because of the original function. So please note if I have spelled something else, if I have said something else, because what usually was happening, that function was not changing, sine was not changing. Over here also what was happening is sine was changing to cos, but both of them are negative at 240 degree in the third quadrant, right? But you have to see the original function. Again, I'll explain it. You don't have to worry about. I'll explain one of them also, right? Let's take for tan. Let's take for tan 330. And let me change it. Let me use the complementary function because that's what the doubt is. So I'm going to write tan 3 pi by 2 plus 60 degree. 270 plus 60 will be 330. It is odd, so this will become cot, right? But you don't have to check for cot, you have to check for tan. Check whether tan is positive or negative at the fourth quadrant. It is negative, that's why we are going to write minus. So minus cot 60, that is minus 1 by root 3. Now I'll just use one more same rule for, so tan 330 and tan, I'm going to write 4 pi by 2 minus, this is 360 minus 30 degree. Is it correct? So now it will not change, it will be tan and this will be 30, and again we are going to look for the original one in the fourth quadrant. So this is again negative, so this is going to be minus 1 by 3. So please note this, that for sign you have to look for the original function that they have given, right? Other than that, please do the homework, please write down all of this in the comment section. Hopefully now you have got it. After this, we are going to, let's start with the next chapter, that is calculus. Very, very, very important. Again, you are going to use it in almost every other chapter. So pay focus. Pause the video, take some break if you want to, but I want you to have the full maximum concentration over here, right? Let's start. We are going to start the calculus with the average rates of change. I'm not just going to explain you the formulas only, right? So just writing down the formulas or mugging up the differentiation rules is not sufficient. Let's talk about the average rate of change. And now, because we have already studied what function is, right? We have studied what function is. Let's suppose I am defining a function y equals to f of x, and I am also drawing a graph of it for you. Let's suppose the graph looks something like this. The graph is somewhat like this, right? And the 2 points are point A and point B. Let me do one thing. This is point B and this is point A. The coordinates of these points are, let's say this is x, this is going to be y, simple things, right? So let's say this point is x, so this point is f of x or y, f of x or y, right? Let's say B is at a finite distance from A. So this means that this distance is going to be, or this coordinate is going to be x plus delta x. Now many of you have this doubt, sir, when do we use this delta? And there is also something that small d in differentiation, in calculus. So where do we use these things? What is this notation about? So whenever you are going to use this notation of delta, delta is for finite difference. Alright, that small d is for infinitely small interval or difference, right? We will come to that. If this is the case, then this value, this coordinate, the y coordinate is going to be f of x plus del x, right? And if I am going to find out the average rate of change for A and B, then what I am going to do is I am going to draw a secant something like this. Intersecting these 2 points. Something like this. This is a secant. A secant is a line which intersects a curve at 2 different points, right? So if you want to find out the average rate of change, what you need to do is, you need to actually find out the angle of this. So the average rate of change will be, it will be written as del y by del x. So del y is nothing but f of x plus del x minus f of x divided by x minus x, sorry, x plus del x minus x, so that will be just del x. This is known as average rate of change. Now, if you have any trouble in this formula, let me explain it to you that this is what you have been doing till grade 9th, till grade 10th, right? In grade 11th, you have studied about instantaneous rate of change. The average rate of change was like when velocity is changed from, let's suppose I am talking about a case in which a body's velocity changes from 3 meter per second to 10 meter per second in 10 seconds. Now please try to understand. If I'll tell you find out the rate of change in velocity, so all you can do is you can find out the average rate of change. Why? Because see my friends, this is what your f of x plus del x is. This is what f of x is. Is that correct? So you are going to write 10 minus 3 divided by del x, that is 10, and you are going to get your answer as 7 by 10 meter per second square, that is average acceleration. This is not instantaneous, this is average. So this is nothing but that's what you have been doing so far, right? So please don't get worried with this graphs, dotted lines, you label it f of x plus dx. You get overwhelmed by these things. Don't do that, right? Don't get overwhelmed. This is nothing but this is the representation of, we are talking in mathematics language, nothing else, right? So you just need to learn a new language, some new words, nothing else. Now what's going to happen is if we really want to find out the instantaneous rate of change. So for that, what we need to do, let's look over here. If we are trying to say that we have to find out the instantaneous rate of change, that means this B point is coming towards A. B is coming towards A. All I am trying to say is the distance between A and B is getting smaller and smaller. So if this del x, this separation del x, if this will keep on decreasing, this secant will at one particular time it will become actually a tangent, right? And then when we are going to find out what del y by del x is, that is what is known as derivative of a function, nothing else. I'm going to again explain it to you. Look over here. All I'm trying to say is let me again draw the graph for you. So this was the point B, this was the point A. So I am saying that this B point is coming towards this point, right? So as it will come at a certain point, here will be point B, and when we are going to draw a tangent, the tangent will be drawn, the secant will be drawn something like this. It will touch this particular point, this particular curve at only one point. And then we are going to say, okay, now we can say that the slope of this line will be the slope of this graph at this particular point, right? And that's why that's how we write dy by dx. Dy by dx. So this is instantaneous rate of change of y with respect to x. That's it, nothing else, right? So this is all very easy, very simple. also one more thing that you must understand over here is that this dy and dx can also be written as, first of all, dx will be written as very small change in x, right? And dy will be written as very small change in y corresponding to the very small change in x, right? So this will be written as very small or infinitely small. If you don't want to write very small, infinitely small change in y with respect to x or change in x. Right, my friends? So sometimes what happens, sometimes you're going to also see something like this, that they have written, you know that acceleration or velocity can be written as, we have got two formulas for, whenever you're going to talk about rate, right, you will have two formulas. One is going to be the average velocity, one is going to be the instantaneous velocity. So that's what I'm trying to say, that let's brush up our concepts for once, and then it will be good forever, right? We can use the same concept again and again in each and every chapter. Else what will happen, you'll feel this pressure that okay, I'll have to again remember this formula, in this one also I have to remember another formula. Rather than that, what we need to do is we just have to remember, okay, acceleration is rate of change in velocity, so it must be of two types, average acceleration or average velocity. It will be written as rate of change in displacement with respect to time, right? If we are going to talk about instantaneous, right, there is something in mathematics that is called as limit. So we say that limit delta t tends to 0. This is how we write instantaneous rate of change. Now what this limit means? Limit delta t tends to 0 basically means delta is so small. So delta t must be something like this, 0.0 and many zeros, and after it might be some values like 1. So this is not equals to 0, but it is tending to 0, right? It is so small that we can assume that it is tending to 0. So if something is written like this, we can, instead of writing all of these things, we can simply write this is dy by dx. Sorry, this is dx by dt. That's it. All right. So this is the terminology in which we work. Velocity same for acceleration, any other physical quantities. Now after this, let's talk about certain rules of differentiation. Now I want you to mug it up, right? So after this after this good 15 minutes of concepts, now we can remember the formulas. We must remember the formula. It's not like we should actually derive all of these things. Derivation does exist for these formulas as well in mathematics, but we are not going to do that in physics, right? So now when we are going to talk about power rule, what does basically power rule means? I'm going to go step by step. Let's suppose that we have got a function. Function is, let's say the function is f of x. Can we give it some another name? Yes, we can call it as y also. And it could be anything. If it is a power rule, I can write it as x raised to the power n. Power variable x raised to the power, raised to some power, right? We want to differentiate it. So how many ways are there to write it? First of all, with you want to differentiate this function with respect to which variable? You can differentiate it with respect to any variable, that is true. But generally what happens, what is the independent variable? X, right? So I'm going to write differentiation of f of x with respect to x will be written something like this, or differentiation of y with respect to x, or differentiation of x raised to the power n with respect to x. All three means the same thing. Usually we write only this thing or this thing, right? After this, the rule is the power comes down and we decrease the power by 1. So this is what the rule is. Power rule, right? So if I'll ask you what is the differentiation of x cube, what is it going to be? 3x square. But it would be really good if you will actually just say this in your mind, or whoever is asking you this question, if you will say to them differentiation of x cube with respect to x, right? Obviously it is 3x square, but it is very important to always look, you're differentiating a function with respect to which variable. It is very important. So differentiation of x cube, sometimes we write it something like this. If we are in a hurry, we put a dash. So we can write it in like 3 terms, 3 ways: f of x, y, or just the function, or a dash over there. So this will be 3 comes down, 3 decreases by 1, so it becomes 2. Root x, differentiation of root x, 1 by 2, power comes down, power decreases by 1, it becomes minus 1 by 2. So this is, right? Or x raised to the power 2 by 3. We have to differentiate this. Power comes down, 2 by 3 minus 1, 2 by 3, x raised to the power minus 1 by 3. This is what the derivative of x raised to the power 2 by 3 is, right? The next rule is, what is differentiation of a constant, right? I have already explained you the geometrical meaning of differentiation as well. Although I have not explained you using a slide, right? But we have got an idea. If we have got a constant, when I was saying differentiation of a function with respect to x, what I was really trying to do? I was trying to find the instantaneous change in y with respect to change in x. Is that correct? Right? So if we are talking about a constant function, it will never change, right? So what is going to be the change in a constant function with respect to change in x? So you are going to say, sir, it will be 0. That's what the derivative of a constant is, right? If you already know this, it will be sounding like pretty simple to you, but I want you to really feel it. I know that you already know the differentiation of derivative of a constant is a 0. I know it, but this time I want you to feel it, right? So that whenever you are going to actually talk about numericals in kinematics or wherever you are facing derivative, you can actually think in mathematics also, in mathematical sense also. So derivative of a constant, let's suppose we have got a function y equals to, a constant k. So the derivative of this is going to be dy by dx, or dk by dx is going to be 0. This is what the rule says. And sometimes what happens, sometimes you can actually understand something like this. Instead of just writing k, can I write it as k times x raised to the power 0? This is absolutely fine. Basically anything raised to the power 0 is 1, not 0, right? So I'll just use the power rule. So I'll bring down this 0 over here. I'll decrease the power by 1. Anything times 0 is 0. But I don't want you to remember it like this. I want you to remember it, okay, my teacher told me that differentiation is instantaneous rate of change in function with respect to a very small change in x. So if we are talking about a constant function looks something like this. Isn't it? The graph of a constant function would look something like this. So you might you might, let's suppose that you are over here, this is what x you are talking about, and this is what y you are getting. So this is your f of x, and then you are saying, sir, this is the infinitely small change in x, although I have actually separated them by quite a distance, but I am saying that this is just an what we can say, this is an I have actually deliberately have enlarged it. This is actually infinitely small. So this distance is dx. What change in f of x you are seeing? No change. So that's why the derivative of a constant function will be 0. Also, when we are going to talk about the geometrical meaning, the slope of a straight line is also 0, right? So you can understand the same concept from everywhere. You are going to reach to the same point. So now after this, let me see if we have got the another rule. Yes, we have got another rule is that if we have got a function f of x which is written as another function g of x times a constant, which we have just done now, right? So for example, if you want to differentiate it, so if you want to actually differentiate f of x with respect to x, what you are going to write it as differentiation of k times of g of x with respect to x equals to k will come out and you just have to differentiate g of x. That's it. So just differentiate g of x and multiply k by it. So if you have got something like a function like 3 root x, don't worry, just write 3 as it is, differentiate root 3x, that will be 1 by 2. This is going to be your final answer, right? Nothing else. If you have got something like a function f of x, a function y which is summation of different functions. So this is important. If you want to differentiate y with respect to x, all you need to do is you just have to differentiate f of x plus differentiate g of x and add them. Similarly for h of x. Also, I can actually, I could write one more step in which I would have written derivative of f of x plus g of x plus h of x with respect to x, then I would have done it, means the same thing, right? After this, let's talk about the product rule and quotient rule also. So for product rule, let's suppose you have got a function y which is written as f of x multiplied by g of x. All right. And just to give them a simple names, I'm going to say that let's suppose that f of x can be written as u and g of x can be written as v. They are nothing but these are just the nicknames of these functions, right? We can do it. So if this is the case, the product rule says the derivative of y with respect to x will be, this is now important, differentiate y, differentiate u and write v as it is. So it will be du by dx and we have written v as it is. Put a plus sign, write u as it is and write dv by dx. This is a product rule, right? We are going to use it when we'll talk about trigonometric functions. Similarly, if you have got a function like y equals to f of x divided by g of x, again I am going to say the same thing. Let's suppose that this is u, this is v. So the derivative of y with respect to x will be differentiate y u, write v as it is, put a minus sign, u times v dash divided by v square. So this is the quotient rule. Easy things. We can actually use them in differentiation of trigonometric functions, right? Again, when you are going to talk about the trigonometric functions, let's start with the sin x. So the derivative of sin x is actually cos x. Derivative of cos x is minus sin x. Derivative of tan x. Now you can use at this time you can use quotient rule. Although this is going to be sec square x, but you can actually expand this. We can use this just to show you how quotient rule works. So the quotient rule works something like this. So tan x can be written as actually sin x upon cos x, derivative of this. So this is going to be derivative of sin x. Let's put cos x as it is. Write a negative sign. Sin x as it is. Derivative of cos x divided by the square of cos x. Right? So this is going to become, this will be cos x. So this will be cos square x minus this will be sin x, and this will be, sorry, this is sec x tan x, sorry, my bad, sec x tan x, my bad. So this is going to be cos square x minus sin x, and by the way this is also minus sin x, right? So this will become plus, actually I was right. So this will become divided by cos square x. So this will be 1 upon cos square x, that is sec square x. I was correct. I got confused with the another one. So the correct answer is sec square x only, right? You can do it for sec x. We'll find for sec x, that is sec x tan x. We are going to find it out, and again you can find it out using the same thing for this one. So sec x can be written as 1 upon cos x, right? That means derivative of this. So derivative of 1 will be 0. So I must not write it. Then derivative of cos x will be minus sin x divided by cos square x. So that will be tan x sec x. So this is going to be sec x tan x. So it's a good way to actually apply the product rule and quotient rule. For product rule, what you can actually do is you can just solve it for yourself. I'm just going to write it. Let's say you have got sin x and root x, or root x sin x. Do it by yourself quickly. Root x sin x. So what you have to do, you have to just select first function. So this is, let's say this is u, this is v. You can do it, you can choose any function as first function, right? So root x, so differentiation of root x, you are going to put sin x as it is, plus you are going to put sin x, root x as it is, you are going to differentiate sin x. So for root x you will get 1 by 2 root x sin x. Over here you are going to get root x cos x, right? So that's it. So for trigonometric function, we have talked about sin x, cos x, tan x, sec x. You can talk about cosec x also, right? Cosec x, cot x. So do it by yourself. Homework is going to be after this one. Solve by yourself for cosec x. Cosec x will be actually nothing but 1 upon sin x and cot x. I've given you 2 problems to solve. Solve it by yourself. Okay. So now let's move to the next. Next topic is differentiation of logarithmic and exponential functions. We are going to talk about these two topics separately as well when we are going to discuss the graphs. But right now, please remember that when we are going to talk about exponential function, it basically means y equals to e to the power x. Right? And the logarithmic function is nothing but the inverse of the exponential function, right? So it looks something like this. If you want me to draw the graph of these two ones, so e to the power x looks something like this. And if we have got a y equals to x line over here, about this we can draw a mirror image. Why I am drawing a mirror image? Whenever you have got inverse function, not going to go deep into it, but inverse functions are the mirror image about the y equals to x line. So this one is going to be something like this, right? So this is y equals to log x to the base e, and this is y equals to e to the power x. Alright, so the derivative of exponential function is actually exponential function itself. So this is very easy, please remember it. And so this is the first formula, and the derivative of log x to the base e or whatever is 1 upon x. So two things really important, right? You're going to use this, and also one more formula for derivative of e to the power of ax. This is going to be a e to the power ax. So remember this as well. Now after this, let's move to the next topic, that is chain rule. This is also important because when you are going to have composite functions. What do you mean by composite functions? Something like this. You have got a function f of g of x. So g of x is a separate function which is acting as an input of f of x, right? So for an example, you can consider, let's say that g of x is actually x square, right? And f of x is sin x, right? So if I'm going to say that, let's write f of g of x. So for this particular case, that is going to be sin of x square, right? So now if we want to differentiate this function, if we want to actually differentiate this whole function, that means derivative of f of g of x will be, first let me write the formula. What you need to do is you need to write down the derivative of f dash, write g of x as it is, multiplied by, write the derivative of g of x. How does it works? Let's take the same example. If we are going to differentiate sin x square, right? By the way, this rule, chain rule, is also known as outside inside rule. Why it is known as outside inside rule? What is the outside function, my friends? Sine. What is the differentiation of sine? So differentiation of sine is cos, and write everything same, right? Whatever inside of this is, write it as it is, right? So cos x square multiplied by the differentiation of x square, that is 2x. So the final answer is going to be 2x cos x square. That's it, right? So that's how the chain rule works. Now, no matter how many functions you have got, you have to do the same thing. Let's suppose that you have got something like, another example. if you have got something like f of g of h of x, right, and you have to differentiate this function. So you are going to write f dash of g of h of x multiplied by g dash of h of x multiplied by h dash of x. Same thing, right? So it keeps on going, nothing else. There's nothing new to the chain rule. It is just for the composite functions. Now let's do some more topics like first order derivative and second order derivative. This is useful when we are going to talk about different things like kinematics, right? So in kinematics, you have got something as displacement time relation. Displacement time relation. When you are going to differentiate it, just now we discussed it, that the derivative of this, that is dx by dt, will be known as velocity, or we are going to get the velocity time relation. Is that correct? Now in the same place I am going to also explain the geometrical meaning of derivative. The geometrical meaning of derivative is, and please note this thing down, geometrically derivative of a function. By the way, when I say derivative or I say differentiation, it means the same thing. Geometrically, derivative of a function is the slope of tangent at a general point. So this is something which is important, and when we were discussing about those average rate of change and instantaneous rate of change, basically we discussed this thing, right? We talked about, do you remember we talked about the slope of the tangent dy by dx. What is that del y by del x? That is tan theta, right? So derivative of xt graph gives vt. That's why we also say that the slope of xt curve gives velocity time. Is that correct? So when you are going to again differentiate it, this can be either called as dv by dt, or the second derivative, and when we are going to talk about the second derivative, we are going to write it something like this. We are going to write it as d2x by dt square. This basically means the acceleration, you are going to get the acceleration time relation. The acceleration is the second derivative of displacement, right? Obviously with respect to time. So that's what we are trying to say. When we talk about integration, we are going to then we are going to come from acceleration time to velocity time, and then to displacement time, right? Or you can also write it as, or this can be written as dv by dt. So dv by dt is exactly equals to d2x by dt square, right? So first order derivative, second order derivative, I think everything's clear till here. Now let's also solve some problems, right? Again, please pause the video, solve it by yourself. I'll give a couple of questions in homework, solve them down, write down the answers in the comment section. X square cos x. So if you are going to talk about x square cos x, for the first one, the dy by dx will be, for x, we are going to first differentiate x square, that would be 2x, and we are going to write cos x as it is, plus x square as it is, and for cos x we are going to write minus sin x. So this is our answer. For the second one, see how we are going to use the chain rule over here. We want to differentiate 6x plus 4 whole raised to the power 2. Try to understand, this whole raised to the power 2 is actually the outside function, right? So if this is the outside function, what we are going to do is, we are going to first treat this as an outside function. 2 will come down. We are going to write whatever is inside, we are going to write it as it is. 2 minus 1 is 1 times, let's go inside, differentiation of 6x is 6, differentiation of 4 is 0. So we are going to get 12 6x plus 4 using chain rule. Hopefully you have got it, right? Moving on, sin x times natural log x. So the derivative of this one is going to be dy by dx. Let's differentiate sin x, that will be cos x. Let's write natural log x as it is, plus let's write sin x as it is, and differentiation of cos x, natural log x is going to be 1 upon x, right? So this is going to be answer. Please do the last one as your homework for the chain rule. All right, moving on to the next one. The next topic is maxima, minima. Now for maxima and minima, this is going to be important whenever you are going to have a question in which the question says, find out the maximum value of a certain thing or find out the minimum value of a certain thing. So please note, whenever, this is an important note, whenever question says, find minimum or maximum value, we have to use maxima minima concept, right? What is it? We are going to talk about it. Let's suppose that we have got a function, something like this. I'm going to draw the graph. Right? Something like this. Done? Now, just by the term maxima, we mean to say we have to find out the maximum values, right? Now, this value will be known as a local maxima, my friends. This value will be known as a local maxima. This value will be also called as a local maxima. If let's suppose someone says that, sir, but see, this value is actually the absolute maxima. No other value in this graph is greater than that value. So I'm going to say, okay, in that case, let's just say that that is the absolute maxima or just maxima. By the way, what we are going to call for this one will be called as local maxima. Local maxima basically means that locally in its neighborhood, this one has got the maximum value, right? So the value of x on which it is having the maximum value, it has also got significance. So let's suppose it is x1, this is x2, and let's say this is x3, and this is called as minima or local minima. So this will be called as local maxima. This one be called as minima. In this particular case, my friends, because we don't have any other minimum value less than this, right? And this is going to be absolute maxima. All right. Now, in the question, they must give you a function, right? A function, this one looks like a quadratic function, right? Or degree, quadratic. It is turning 3 times, so it must be a cubic function. So they must give you a cubic function and they'll ask you that find out the maximum and minimum value, or maximum or minimum, any value they would ask, right? So how will we find? So first of all, let's try to look at this graph. Let's try to look at this graph and let's try to find it how we can actually find out local maxima and minima. To find it out, the prerequisite of this is one knowledge that geometrically dy by dx means slope of tangent at any point. Is that correct? Right? And how do we find slope of tangent? What we do is, let's suppose that you want to find out the slope of tangent at this particular point, right? So let's draw a tangent at this point. Let's draw a tangent at this point, something like this. So actually the tangent will be drawn somewhat like this. So I have drawn it. Hopefully everything's clear. Right? Done. After this, what we are going to do is, we are going to actually measure the angle from the positive x-axis in the anti-clockwise direction. And let's say that is some theta, some angle. So because the angle is measured in the anti-clockwise direction and the angle is acute, that is less than 90 degree, we are going to say that at this particular point, the slope is positive. That means dy by dx is greater than 0. Right? Hopefully you can see it. At this point, dy by dx is greater than 0 because of two things. First is basically because of one thing, because angle is less than 90 degree. That means acute angle. And tan theta will be positive for acute angles, right? Now, at this particular point, what do you observe? At this particular point, what do you observe? At this particular point, we are going to say that, sir, dy by dx is exactly equals to 0 over here. This is actually important because this point is also sometimes known as stationary point. Is that correct? Because the tangent becomes parallel to the x-axis. And if we are going to find out the slope at anywhere at this point, the slope, the angle will be actually greater than 90 degree. It will be greater than 90 degree, which means that slope will be negative, right? So for this point, dy by dx is less than 0. Now hear me out. Let's suppose that we are talking about point x1, right? So at x1, how the slope is changing, let's figure it out. So the change in slope is first it was positive, that is before x1, then it became 0 at x1, then it became negative after x1. You tell me, is everything clear with this concept? See the diagram. See the definition of maxima, local maxima. When you are going to get a peak, when on the right hand side, like for example, if I am seeing the graph something like this, right, like you are seeing it. So on the left hand side of the peak, the gradient should be positive. On the right hand side of the peak, the gradient should be negative. And on the peak, obviously the gradient will be 0. Right? So can you tell me what is the rate of change in slope? Can you tell me what is the sign of rate of change in slope? It is very simple. Let me explain. what I am asking you. I am asking you that what is rate of change in slope. You are going to say, sir, slope is actually itself a rate of change in y with respect to x. I'm going to say no worries. Let's not worry about it. We know that slope is, let's say it is m, it is dy by dx, right? So if I am talking about rate of change in slope, this would mean dm by dx. As you are moving in x, how the slope is changing. So instead of m, I can substitute dy by dx. So this would become d2y by dx square. That means the double derivative of y with respect to x. That's why I have already explained what double derivative is. This means that the double derivative, it was first positive, then it became 0, then it became negative. That means the rate of change of slope should be less than 0. So this should be less than 0. This is the important thing for maxima. This is the condition for maxima. Alright, my friends, right? This is the condition for maxima. First thing you need to do, whether it is maxima or minima. Now I'll be a little quick. When you're going to find out the minima, derivative on the right side is derivative on the left side is 0, then derivative on the right side will be positive. That means for minima the condition will be d2y by dx square should be greater than 0. Alright. Now shall I break it down? How you are going to find it out? Same thing for this one as well, right? Same thing for this one. You are going to ask me, so sir, how we are going to find out whether we are talking about local maxima or local minima? Just compare it, dosto. Just compare it, friends, right? If let's say this is the value of this is coming as 100, it must be greater than 100. So you will be easily able to identify which one is the local maxima. So the condition over here is to find out the steps that you want me to write for you is something like this. I'll write the steps over here. And the steps is how to find maxima or minima, right? So the step is step 1. Step 1 is going to be find dy over dx equals to 0. Find the points where dy by dx is equals to 0. Let's suppose you are getting some 3 points. Is that correct? You are going to get 3 points. 1, 2, 3. x1, x2, x3. You are going to get 3 points. dy by dx is 0 at 3 points. Now you don't know whether it is a maxima or whether it is minima. That's what the problem is. The second step is and the solution for this is, let's say x1, x2 and x3. Next, find d2y by dx square and check for x1, x2 and x3, right? Check for x1, x2 and x3. If this is the condition, if substituting, let's say if you are substituting x1 and it is coming out to be less than 0, that means at x1 it is maxima. If it is coming greater than 0, that means it is minima. That's it. Game over. Right? So friends, with this, let's solve one or two more questions. And this is going to be a question which is poll based, right? So obviously this is a recorded, this one shot is in the recorded form, so we don't have poll over here. So what you need to do is you need to actually write down the answer in the comment section and pause the video and solve it by yourself quickly. Pause the video, my friends, do it by yourself. Hopefully you have done it. If x denotes the displacement t, x equals to a cos theta, then acceleration is. You are going to say me, sir, this is the question from kinematics. Why are we solving this right now? But you tell me, if you are able to find out what differentiation is, then how is it the question of kinematics, right? Let's just solve it. So x is actually equals to a cos t. So velocity will be dx by dt. That is minus a sine t, and acceleration will be d2x by dt square or dv by dt, that will be minus a cos t. Again differentiate sign. So minus a cos t, that means option B. Hopefully friends, you have got the correct answer. Right? Moving on. A particle moves along a straight line such that its displacement at any time t is given by s equals to t cube minus 6t square plus 3t plus 4, the velocity when the acceleration is 0. Can you do it this one? When acceleration is 0, what does it mean? It means that just differentiate the displacement twice. So d2s by dt square equated to 0. Find out the time from here. Find time. Substitute this time in ds by dt. This is your answer. Right? So this is for your homework. Please do it. Write down the answer in the comment section. Right? Moving on. So this was the slide number 44. If you want to write down in the comment section, this was slide number 44, right? So now let's move to the next topic of calculus, that is integration, right? Please remember the geometrical meaning of differentiation. We have completed the differentiation part, and now let's move to the integration part. When we are going to talk about integrations, there are different definitions for integration, and there is also a geometrical meaning for integration. We are going to talk about both the things. But first of all, integration can be defined as, well, it's not the best definition, but surely it can be defined as, it is the reverse process of differentiation. It is the reverse process of differentiation, right? What do we mean by this? Let's suppose that we have got a function f of x and we were differentiating it and we were getting another function that was f dash of x, and I am actually, instead of just writing f dash of x, I am naming it as a new function. I am calling it as g of x. I can do it, right? There is nothing wrong in it. So these functions are known as derivative of f of x, right? So what is the process of getting derivative of f of x? You are going to say, sir, just differentiate it. So this function can be also called as antiderivative of g of x. So the process of getting the antiderivative of a function is known as integration. So this was differentiation, this is integration. Alright. So when we are going to talk about, let's say that we are saying sine x, differentiation of sine x is cos x. So if I'll integrate the cos x, I should get the antiderivative. Antiderivative of cos x. What is that? Sin x. Please don't mind the symbol and the letter. I'm going to explain it for you. Right? So basically what integration basically means is, this symbol basically means to integrate. Then you have got a function f of x, and then you write the variable with respect to which you are trying to integrate the function. You are trying to find out the antiderivative of, right? So what is the geometrical meaning of all of these things? So the geometrical meaning of this thing over here is to find out the area under the curve. So let's suppose that we have got x-axis over here and we have got a function something like this. This is a function. I have not drawn the y-axis for now, right? So now what I'm going to do is, let's suppose I want to find out the area. What I'll do is I'll just draw a very thin strip, something like this, and this thin strip has got a thickness of dx, and it has got a height. This point will be known as y, or it will be known as f of x, right? So the area of this thin strip will be f of x times dx. Now if I have to find out the area under this whole of curve, then I'll use an integration sign, which, I mean, if we have got like discrete values, we used to use the sign of summation. In like grade 9th in statistics, you have used the sign of summation. It is quite similar to that, but right now we don't have got discrete values. We have got continuous values. We have got continuous strips over here, right? So we use that. That's all. You don't have to go really deep into what these things are. A decent amount of concept, a decent amount of information is good for you, right? So this is all that you need to know about the integration. Now again, in this one also you have got the same sorts of rule. You have got power rule over here as well. In this one, the power rule will work something like this. You have got x raised to the power n with respect to x. This will be x raised to the power n plus 1 divided by n plus 1 and an integration constant c. Why we are using an integration constant c? We are going to actually discuss that as well, right? So first of all, when we were talking about differentiation, we were saying that let's decrease the power by 1 and let's write it in the numerator. And to find out the antiderivative, we are going to do the opposite thing. I'll explain it. So let's suppose you have got a function like 3x square, right? And I want you to integrate it. Sorry, I want you to differentiate it. So if you will differentiate it, you are going to actually get 6x. Is that correct? You are going to get 6x, which means even if you don't remember any integration formula, let's suppose you don't remember any integration formula. So you will say me, sir, but you have explained us that the antiderivative of 6x will be this. So this is going to be 3x square. That's it, sir. Right now I don't remember any formula, I don't know anything, but just now you told us that if this is the derivative of f of x, then if I'll integrate this one, I'll get f of x. Easy thing. Same thing I've done over here as well. So if this is the derivative of this thing, if I'll integrate 6x, I'll get 3x square. Fair enough. But hang on. The catch is, let's suppose you have got something like 3x square plus 2. Let's differentiate it. 3x square differentiation is 6x. Differentiation of 2 is 0. So again we are getting 6x. So now if I'll again integrate 6x, what should I get? Shall I just write 3x square or shall I write 3x square plus 2? Are you able to understand the problem we are getting? The derivative is same for two different functions. So if I want to integrate that function, what shall I write? What should be the correct antiderivative? So I don't know what that correct antiderivative is. That's why I have written an integration constant over here. So I am saying that integration constant can be anything. It can be 0 as well. So it will depend, it can vary to quotient, right? So this type of integration is known as indefinite integration, in which we don't know what is the value of indefinite integration. Right? Also, you are going to figure it out after when we'll discuss definite integration, that there's something that is called as limits. That means we were talking about integration as it is the area under the curve. So area under the curve up to which limit? From where till where we have to find out the area. So let's suppose I am saying that let's find out the area from x equals to a to x equals to b. So this is going to be called as the lower limit. This will be called as the lower limit, and this will be called as the upper limit, right? So if you already know what lower limit and upper limit is, then we can say that we don't have to use the integration constant. Then we actually know what the function is, what the antiderivative is, right? We are going to come to that. But for now, whenever you don't have any limits, please make a habit of writing integration constants, right? So if you have got a constant, let's suppose you want to integrate k with respect to x, so you are going to just write kx plus an integration constant c. You want to know how? It's quite easy. Same thing. Initially you are writing it as k times x equals to x raised to the power 0, right? So if you want to integrate it, just use the power rule. So it would be k x raised to the power 0 plus 1 upon 0 plus 1 and plus an integration constant c. That's it. Moving on, after this, if you have got a constant attached to the function, there is no difference. The integration of k times g of x will be same as k times the integration of g of x. No big deal. If you have got y equals to f of x plus g of x plus h of x, the integration would be the integration of the whole function y with respect to x would be the sum of integration of individual functions, and then we are going to add them. All right. So after this, now it's again trigonometric ratios. It's quite easy thing. You already know what differentiations of these functions are. Like differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Differentiation of tan x is sec square x. Differentiation of sec x is sec x tan x. Differentiation of cot x is minus cosec square x. Differentiation of cosec x is minus cosec cot x. Right? After this, if you are going to talk about the integration, so integration of cos x is going to be sin x plus integration constant c. Integration of sin x would be, now you are going to figure it out that there is nothing as integration of sine, differentiation of, there is no function which gives the, there is no function if you are going to differentiate it and we will get minus sin x, we will get a sin x, right? But we have got something which is minus sin x. So we are going to put this minus sin x over here. So this is going to be minus cos x. Alright. After this, differentiation of tan x, not tan x but sec square x, that will be tan x. So now you know the drill, now you can do it. Other than this also sec x tan x minus cosec square x minus cosec cot x, it's quite easy now for you, right? So do it, fill the rest once. I'll move on. There are some really important formula for you to learn. If you have got like ax plus b whole raised to the power n, you want to integrate it. It's quite easy. Just add 1 to the power and write n plus 1 and write a. Right? Please remember this because sometimes it might come. Similarly, if you have got 1 upon a plus bx, you have got 1 upon b natural log a plus. This one comes because of a fact that when we are going to talk about the integration of 1 upon x, right? Please don't use power rule over here. Actually, you can't use power rule. So this is going to be natural log x. So this is the formula from which we have actually derived this formula. Although we can derive all of these things using integration by substitution, but that's not of a use, right? That's not of a big use. All we need to do is we can actually convert 1 upon b plus x into some other variable and then we can do it. But why we have to take all of those things, right? You can just remember these formulas, very important. Then e to the power of ax, 1 upon a e to the power of ax sine ax plus b will be minus 1 upon a cos ax plus b. Again, I am telling you, you can easily do it using integration by substitution method. It's not in the course for NEET student, right? Cos ax plus b will be 1 upon a sine ax plus b plus an integration constant c. Then we are going to talk about some of the standard graphs. In standard graphs, the first graph that we are going to look for is a straight line. And when we are going to talk about a straight line, the equation of a straight line is given as y equals to mx plus c. Here c is the y-intercept, m is the slope. So m is the slope, which is going to be constant for a straight line. Slope basically means dy by dx, and c is the y-intercept. Right, so now I'm going to draw different lines for you. So let's suppose this is y-axis, sorry, this is x-axis, this is y-axis, and different lines are something like this. Let's say I'm drawing a line something like this. Let's suppose this point is minus 2, this point is 2, right? This point is 5, this point is 10. So this equation of this line is going to be y equals to 10. That's it. Equation of this line is going to be x equals to 5. And an equation of this line is going to be, just figure it out. See, the y-intercept is minus 2, right? And what is the slope of this straight line? Can you find out the slope of this straight line? Quickly do it. The y-intercept of this straight line is c is actually equals to minus 2. Right? Now you can actually take any other point, like for example as this point is 2, 0, right? Just substitute it over here. So y is 0, m times x is 2 and the y-intercept is minus 2. So you can find out the slope is coming out to be plus 1, right? Slope is coming out to be plus 1. So the equation is going to be, for this one, the equation is going to be y equals to slope, that is 1 x minus 2. So this is going to be the equation of this straight line. That's it, right? So different lines, horizontal, vertical and an inclined line. A straight line basically means that it will have a constant slope all over. After this, let's talk about parabola. And along with parabola, we can also discuss quadratic equations, right? So this is a parabola. It is defined as y equals to kx square, and this is known as an upward parabola. Right? And the general equation of this parabola is y equals to kx square. That means y is directly proportional to x square. What does it mean? It means that you are going to move unit places on x axis, but on y axis the change is going to be much larger. That's why the graph is moving towards something like this. So it's a way for you to quickly understand that if you have got something like y is directly proportional to x square or y equals to k square kx square, it would look something like this. Just opposite to this, if you have got a minus kx square, that is going to be a downward parabola, but still the parabola would be moving towards the positive negative y axis. If you have got something like x is directly proportional to y square, in that case you are going to have a parabola something like this, that the graph is going to move towards the x axis, right? This thing is very important. Similarly, when you are going to talk about minus ky square as well. Now, these things are important because when you are going to talk about parabolas, let's also discuss when we have got situation something like this. We have got like three types of situations. One is we have got an upward parabola, something like this. We have got an parabola something like this. And let's suppose we have got a parabola which is not at all intersecting. So these are the three types of conditions in quadratic equations. Normally the quadratic equation is given as y equals to ax square plus bx plus c. This is generally the equation for quadratic equation. Now, when somebody says to find out y equals to 0, now there are three possible cases. The first case is this, in which we have got two distinct solutions or two distinct roots. So here we have got two real and distinct roots, right? This means that when you are going to find out the quadratic formula to find out the solution for this, this implies that ax square plus bx plus c equals to 0. This means that the solution for this one will be given as x equals to minus b plus minus under root b square minus 4ac divided by 2a. So this b square minus 4ac, this is known as discriminant, just for your information, right? In somewhere it might you might use it. So in the first case, the discriminant is actually greater than 0. In the second case, the discriminant is actually equals to 0. And because in the third case you don't have any real solutions, the discriminant will be less than 0. So you have got imaginary roots. That's it. That's all you need to know. You have already learned all of these things in grade 10th also, right? After this, this is actually something which is more important than the parabola. Why? Because you might have seen that there are many problems, there are many formulas in which you see a relation something like this, that x is inversely proportional to y, right? Or y is inversely proportional to x. First of all, this type of a graph, you need to understand two things. This graph is known as rectangular hyperbola. It is being drawn something like this, and it is applicable for xy equals to constant. Do you remember that PV equals to constant? PV equals to constant when temperature is constant, right? That means pressure is inversely proportional to volume. So how we are going to draw the graph? Like this, right? This is an example. Or potential is equals to KQ by R. This is again from grade 12th. So here also potential is actually inversely proportional to R. So again the graph will be drawn something like this. So wherever you are going to see something like, see a relation something like this, you are going to draw a rectangular hyperbola. With this, now for a circle and for an ellipse, it's just a matter of equation in how you draw it. For a circle centered at center, centered at origin, the equation is given as x square plus y square equals to a square, where a is the radius. That's it. If the center is not origin, we can write down the equation of a circle, but I have never seen that we are going to use those things in NEET. But that is not that difficult, right? But you must be able to understand that that's how you write the equation of a circle. For ellipse, the equation is x square upon a square plus y square upon b square is equals to 1. In ellipse, you have got two axes. This one is called as major axis. This one is called as minor axis. That's all, right? Now, after this, let's start the next topic, that is binomial expansion. Now, the next topic is binomial expansion. So, before starting the binomial expansion, it is going to be used in one or two places, right? But still, as I have told you, it's a small thing. It's better that we complete this topic as well. Before starting binomial expansion, there is something that is called as factorial, right? A very easy thing, not to be worried of factorial. It is related with mathematics. Obviously, you're going to say, obviously, sir, you're teaching basic math today. Factorial basically means that let's suppose that I am writing 2 factorial. So 2 factorial basically means 2 times 1. It is a way in which it's a number of ways in which we can represent a number, represent a data, right? So let's suppose we are writing 3 factorial. So 3 factorial is going to be 3 into 2 into 1. Then 4 factorial, similarly you got the you have got the idea. So n factorial would be n into n minus 1 into n minus 2 and so on till you reach 1. This is what factorial basically means. In this one, the 0 factorial is 1. This is a little counterintuitive, but just now I have told you that it is the number of ways in which you can arrange a data or arrange a number, right? So if you have got like 0 number of items, if I've got like 2 items, in how many ways I can arrange it? So I can arrange it in 2 ways. Let me explain it. Let's suppose that I've got 2 items A and B. In how many ways I can arrange it? In 2 ways. One is AB, the another is BA. Is that correct? So there are 2 ways. If I've got 3 items, I can arrange it in 6 ways. Like A, B, C, A, C, B, C, A, B, and then so on. Please, let's not waste our time on this. You got the idea? So if I've got like 0 items, so in how many ways you can arrange it? So it is actually arranged in one way, that there is no way. It's counterintuitive, but that's what it is, right? So now the thing is, 0 factorial is 1 and the other things are something like this. What we are going to do in binomial expansion is, what we are going to use over here is, this is just for the use of binomial expansion. In some of the books, they don't teach it like this, they don't give it like this, they just explain the formula of binomial expansion. I think that to remember that formula, it is slightly difficult than what I am trying to teach. So for binomial expansion, let's suppose that you have got something like x plus y whole raised to the power n. And that's why we use binomial expansion. If I would have said to you that just expand x plus 2 whole square or x plus 2 whole cube, you would have done that because you already remember those algebraic expressions, right? But if I'll say expand this or find me the 10th find me the second or find me the expansion of this number. That would be quite painstaking, right? That's why we use binomial expansion. And in physics, why we use binomial expansion, I'll tell you. So the binomial expansion of this one is going to be NC0 x raised to the power n y raised to the power 0. Now again there is also one more thing. This is NC. What is this NC? This is known as combination. So NCR, the formula is going to be n factorial divided by r factorial multiplied by n minus r factorial. Again, nothing to be worried of. Easy thing. Example, let's take an example. Let's say what is 3 factorial 1, 3c1. Sorry, not 3 factorial 1, 3c1. So this is going to be 3 factorial divided by 1 factorial multiplied by 3 minus 1, that is 2 factorial. Now just solve it. 3 factorial is 3 into 2 into 1 divided by 2 factorial is 2 into 1. The answer is going to be 3. That's it. So it's easy, right? So the expansion is something like this. This is the first term plus NC1 x raised to the power n minus 1 y raised to the power 1. Now you slowly, by each term you increase the power on y, you decrease the power on x till you get something like this. NCN x raised to the power 0 y raised to the power n. That's it, my friends, right? And it works. It works beautifully. It will always work. You can use this to find out the expansion of x plus y whole square. Do it by yourself, right? Why we are using it? We are using it because let's suppose we are talking about 1 plus x whole raised to the power n. We are using it for this thing. 1 plus x raised to the power n. So this will be written as NC0 1 raised to the power n x raised to the power 0 plus NC1 1 raised to the power n minus 1 x raised to the power 1 plus so on. The higher values of x, I'll write 1 or 2 plus NC2 1 raised to the power n minus 2 x raised to the power 2 plus NCN 1 raised to the power 0 x raised to the power n. Is that correct? Hopefully you have got the idea what we are talking about. Now to solve this, what is NC0? So NC0 is nothing but it is going to be 1. Please remember NC0 is going to be 1. How? NC0 is going to be n factorial divided by 0 factorial multiplied by n minus 0 factorial. So n minus 0 is n, cancel out, 0 factorial is 1. So the answer is going to be 1. So this is going to be 1 x raised to the power. So this is 1 plus this is NC1. What is NC1? Let's find out what NC1 is. Do we have space? Let me do it over here. NC1. So NC1 would be n factorial divided by 1 factorial multiplied by n minus 1 factorial. How to solve this one? See how we are going to solve this one. N factorial can be written as n times n minus 1 factorial divided by 1 times n minus 1 factorial. We can cancel it out. This is going to be n. If you are having trouble, please look at here. From this point till 1, this is nothing but n minus 1 factorial. Right? So this means that this is going to be nothing but this is going to be n. This is x. 1 raised to the power anything is 1. This is x and so on. Right? Done. And the greater values until the last term is going to be x raised to the power n. This is the expansion of 1 plus x raised to the power n. This is very, very important. This is what we are going to use. And how we are going to use it, I'll tell you. We are going to use it in such a way that we are going to say that if x is very, very less than 1, if x is far less than 1, then the expansion of 1 plus x raised to the power n can be written as just 1 plus nx. That's it. This is the, you're going to actually, you're going to be a little angry with me. You're going to assume that, okay, for just only this short expression, have we learned all of these things? My answer is yes. And I think this is the better way to do it, even if we are aiming to crack NEET, right? It will give you a little confidence. See, this is not difficult. It will take just 10 minutes to crack all of these things, right? So generally the expression is something like this, but in physics, usually what's going to happen is, whenever you have got something like 1 plus x raised to the power n, please note somewhere in the condition, you will have this, that x is very, very less than 1. So if x is very, very less than 1, what will happen? Okay, what will happen? If x is very, very less than 1, the higher values of x can be neglected, right? The higher values of x can be neglected, and we are going to be left with only 1 plus nx. That's it. And I'm going to give you an example of this also. The we can understand this thing. I mean, in gravitation, if you remember, we were finding out the gravitational field, the intensity of gravitational field at a distance of h from the surface. So which means this is radius and this is h. So the total height becomes r plus h. Right, my friends? Hopefully you can see it. So if you want to find out the gravitational field at that point, I would have written it, G dash will be equals to G m upon r plus h and square of this. So I'll take out that m from here, and I'll write r square, and I'll be left with 1 upon 1 plus h upon r. Can you please see? Right? Is that correct? And now in this case, h upon r, because h is very, very less than r. So in this case, now we can use our binomial expansion, and also we are going to use that minus sign, right? So that's how we are going to do it. Please try to understand. This is because of these few applications we have done it. After this, we have already done what logarithmic is. You must actually understand two formulas. One, this is not a formula, this is just a way of writing the number e. It is the value of e, not the way. It's the value of e, 2.7183. And if you want to convert the base from 10 to e, you can just multiply 0.4343. And why I have drawn this, just to show you, we have already done this, that this is the e to the power of x graph, and this is going to be the log x graph. These are the inverse of each other. That's it, right? E to the power of x, this is log x to the base e. If some of you have a little bit of doubt in logs, please try to understand that if you have got something like y equals to e to the power of x, this thing is known as base. Obviously, this is known as power, and this is known as output. So, converting this into log, we can write log y to the base e will be actually x. Alright. So if you have got like log of m cross n, it will be written as log m plus m. M divided by n, it will be written as log of m minus log n. These are some of the most basic things, right? But you need to understand it. And also, if you want to change the base from e to log 10, 2.303. These two formulas, please remember it. Because they can give you the quotient in base e, and they can ask in some another base. So this is very important first, and this is the second, that from log, you can also use the base change formula, but still remembering these things will always help you. After this, you have got one more topic, and then then we'll be left with the vectors only. That is series, and in this we are going to talk about AP and GP. AP basically means arithmetic progression. What do you mean by arithmetic progression? when we are going to talk about AP, AP basically means that let's suppose that you have got a first term, and then for finding out the next term and the successive terms, there is a rule, and that rule, let's say this is AN. That rule is because of a common difference. What that common difference is? Let's suppose that common difference is D. So if you are going to add a common difference into A1, you are going to get A2. Then if you are going to add a common difference, you are going to get A3 and so on, right? So for example, as let's say you have got 3, 5, 7 and so on. It's not necessary that common difference should be a whole number or an integer or positive number, nothing like that. It can be anything, but it should be constant. In all of these cases, the common difference is always written as nth term minus a preceding term. That's how you always write a common difference. This is the only way in which you can actually figure out how we are going to write whether a progression is an arithmetic progression or not, right? So d small d is going to be an minus 1. If you want to find out the nth term, let's suppose you want to find out the sixth term of this AP, right? This is the sixth term of this AP. So to find out the sixth term of this AP, what we are going to do is we are going to actually use the nth term formula. This is nth term formula. So the nth term formula says you just have to write first term A, so this is the first term, plus n minus 1 times D. It makes complete sense. So this is your first term. This is n, the position of which we actually want to find it out, right? So if this is the sixth, right now we are going to write 6, and this is nothing but this is common difference. Alright, so this is the nth term formula. Last, if you have to find out the sum of these n terms, so sum of n terms will be found out by sum of n terms of an AP. The formula is Sn is equals to n by 2 times 2a plus n minus 1 into d, or Sn is equals to first term plus last term, or yeah, you can remember like first term and last term also, you can remember it like n by 2 first term plus nth term. So you can substitute the nth term formula over here. So you are going to come up with the same thing, right? Or you can also write down the last term over here. So this is all about AP. This is again part of 10th. So it's like more like a formality for us. Why? Because this is, you can also learn it on yourself, right? By yourself. Differentiation, integration, all the calculus, trigonometry, those were the pretty important topics. These are quite simple. Similarly, when we are going to talk about a geometrical progression, in geometrical progression, what's going to happen? In arithmetic progression, we were talking about a common difference, right? That common difference could be anything. It's not necessary that it should be a positive number. When we are going to talk about a geometric progression, we are going to say that we will not talk about a common ratio. That is a number, let's say a R. We are going to multiply it with a to get the next term. So we are going to get like AR square and so on, like the nth term, right? So again, if this is the GP, then the common ratio will be an divided by an minus 1, right? And the other formulas for this one are going to be something like this. So if you have to find out the sum of a GP of n terms, A is the first term, r raised to the power n, r is the common ratio and n is the number of terms you want to add. If let's say now we are not going to use the n terms, we are going to use for the infinite terms. So this is actually important for us. This is important for us, right? So if we have got infinite number of terms in a GP, the sum is going to be a upon 1 minus r. Very, very important, particularly this thing. If r is greater than 1, usually we don't see something like that. If r is less than 1, between 0 and 1, use the formula a divided by 1 minus r, right? So with this, now let's start the vector algebra. Let's start solving this. Hopefully you have understood each and everything till now. So in this topic, we are going to start with what do we really mean by vector quantities, how we are going to define scalar quantities. Let's first start with the basics. See, we can say, you must have already talked about what do you mean by physical quantities, right? Any quantity, those quantities which can be physically measured using some instruments are known as physical quantities. Now, out of those physical quantities, some physical quantities can be categorized as scalar quantities and some as vector quantities. Now, one type of definition can be that scalar quantities are those quantities which have only magnitude to define themselves, and vector quantities are those quantities which have magnitude as well as direction. But I would like to expand this definition and also note one more thing, that surely they have got magnitude and direction, and they also obey the vector laws. Right? So this is actually one of the most important thing, that vector quantities are those quantities which have direction, they have magnitude, direction, and they obey the vector laws. Like for example, as those laws can be law of vector addition. So for example, you have got, if we are going to talk about an electric current, surely an electric current, in electric current we talk about direction. But so let's say that we have got 3 wires over here. We have got current I1, we have got current I2, and this current I3 can be written as, using the current law, it can be written as I1 plus I2. But we are not going to find the value of current I3 using the vector laws. So current is not a vector quantity for us, right? Other than that, let's not go into tensor quantities, because those things are actually, they are more complex as they look, right? So for us, it's quite easy. If a quantities have only magnitude and they don't obey vector's law, right? So they are going to be scalar quantities. For vector quantities, this is going to be the correct definition. Now let's talk about the representation of a vector. So we have already talked about that vector quantities are those quantities which have magnitude and direction. So in space, now please understand, whenever we are going to talk about space, this is a term, space, we mean to say a 3-dimensional world. And in mathematics or physics, this 3-dimensional space will be given with the help of a Cartesian, Cartesian plane, Cartesian system. So in the space, you know what space means. The representation of a vector will be defined by an arrow, and the length of this arrow is going to be the magnitude of the vector. So this length, whatever the length is, this is going to be the length is going to define the magnitude of the vector quantity, right? And it will be written with you can write it with any letter. Let's say it is being represented by A and an arrow over it, right? Plus with magnitude you also have to describe the direction. So for direction, what you can do is, let's suppose that if this is a Cartesian plane and this is a vector quantity in space, then what we are going to do is, we are going to actually draw a line parallel to x-axis and we are going to measure angle in the anti-clockwise direction from the positive x-axis. So this is going to be the angle. That's how we are going to actually define the direction for this vector quantity, right? Now if they are going to talk about angle between two vectors, so before moving to two vectors, also please understand that this is known as head of the vector. Head of vector. Now this is very important because this is going to actually show that in this direction this vector A is being. This is going to be called as the tail of vector. So if you want to find out the angle between two vectors, all you need to do is, let's suppose you have got a vector over here like this and you have got another vector something like this. Now please understand, I can move this vector parallel to space anywhere I want. There will be no change in this vector quantity, right? I'll again expand this concept, but before that let me move it to something like this, such that their tails coincide. This is the only way to measure the angle between two vectors, when their tails coincide with each other. Then we calculate the acute angle between them. So let's suppose this is vector A, this is vector B. So that is how we are going to actually find out the angle between those two vectors. I'll again explain why is it legal, why is it valid to move a vector parallel in the plane anywhere we want. Because see, a vector is much like our names. Like for example, as my name is Subrat Sharma. So my name is made up of two things, my first name and my last name. That's what makes my one part of my identity, that is my name. Similar to this, a vector has got two things, magnitude and direction. Now magnitude basically means the length of the arrow. So if you are going to move parallel, if you are going to move this vector parallel in space, the length is obviously not going to change. And if you are moving parallelly, then the direction is also not changing. That means both the things remain same. So it means that you can move the vector parallel in space and also the direction, the vector will not change, right? It will remain same. So hopefully everything's clear till here. After this, now let's talk about types of vectors. So if someone says that we are talking about parallel vectors, what do we mean by that? By saying parallel vectors, we mean to say that let's suppose we have got a vector something like this and we have got another vector something like this. It's not necessary that their magnitudes are same or different. It's just that they must be in same direction, right? Their magnitudes can be different. So please note that their magnitudes, just a second, their magnitudes can be different, right? So for example, as its length is greater than this vector. So let's say this vector is A and this vector is, let's say this vector is B, but their direction are same. So for parallel vectors, please understand, for this one, directions must be same. So this means that if you have got two vectors, you can write it something like this, that B vector can be actually written as a constant lambda times a vector A. Why is that? Because please try to understand that this constant is the thing which is actually changing the magnitude of the vector, right? So for example, as let's suppose that A vector is 3 meter in a particular direction. I'm just taking the length to be a vector quantity, right? So just multiply a constant with 3. So for example, as 2 times of vector A. So this one will become 6. 6 meter is going to be the length of this vector quantity and in the same direction, right? After that, if you are going to talk about, this was parallel vectors. If you are going to talk about equal vectors, This means that now this is very easy. This would mean that they have got two vectors which have equal magnitude and same direction and are in same direction. So make no mistake, if someone is saying that two vector quantities are equal, then we are not going to actually worry about direction or magnitude. Everything will be same. Both the things are going to be same, right? And then we are going to say that in that particular case, let's suppose two vectors are equal, let's say vector P and Q. So something like this. So this means that everything is same. Magnitude is same. Their direction is same. They might be on different positions in a space. But if you are going to parallelly shift them, they will perfectly overlap, right? So those vectors are known as equal vectors. What are anti-parallel vectors? Anti-parallel vectors are going to be, let's suppose that we have got a vector A something like this. Right? If I would draw exactly a vector something like this, so this is going to be called as equal vector. Done. If I would draw a vector something like this, but I'll change the length, then this would be known as a parallel vector. Good till here? So I'm just giving you a revision of whatever we have done. Hopefully everything is clear, right? But what if I'll do something like this, I'll actually I'll draw a vector whose direction is exactly opposite to my initial vector, and please understand the length may or may not be equal. I mean I'm not always saying that it's not like equal vectors are not parallel vectors. Equal vectors are also parallel vectors, right? But the converse is not true. Parallel vectors may or may not be equal because there is a problem with the length, right? So if B was exactly equals to A, I had no problem because lambda can be 1, na? Lambda can be 1. There is no issue with that. Similarly, with this one as well, the direction must be different. So for this one, I'm going to write something like B vector will be written as negative times of lambda times A, where lambda will be a positive constant now, right? Hopefully now you can you have a better idea. And now negative vectors basically means that let's suppose that I am writing that vector P is actually equals to negative times of Q. What does this mean? This means that directions are opposite but their magnitudes are same. And by the way, magnitudes are being defined by the modulus signs, the mod signs, right? This is not necessarily true in the anti-parallel vectors case. Moving on, collinear vectors. Collinear vectors basically means, again, basically it's the same thing as we can define it as parallel vectors only, so that there is not much of a difference. Collinear vectors basically means something like this, that you have got a vector and in line of that you have got like another vector, right? So not much difference. Co-initial vectors basically means that vectors which have got same starting points. We have got same starting point. This is what co-initial vectors basically means. Co-planar vector means, first of all, you must understand what plane is. Hopefully you know what plane is, right? Two-dimensional, two axes make a plane. So let's suppose that this is x-axis, this is y-axis. So this is a plane, xy plane, right? A flat surface. So first of all, please try to understand that any two vectors are coplanar. Any two vectors are always coplanar. You can always make a plane out of two vectors, are always coplanar. So whenever we are going to talk about coplanar vectors, we are going to talk about at least three vectors. Is that correct? Right? So three vectors are going to be coplanar if they share the same plane. That is what the definition of coplanar vectors is. For this one, we are going to write if 3 or more vectors are in same plane, or parallel also, right? Same or parallel plane, then these are known as coplanar vectors. Concurrent vectors, what do you mean by concurrent vectors? Same definition for we are going to talk about concurrent vectors as well. It will be quite similar to what we have talked about in co-initial and collinear. So in this one, like they had a common point from which they were originating. In this one, we'll just say that they have got a common, point, something like this. These are concurrent, that they have got a common point, right? So with this, let's move to a question. The question says a man walks towards east with certain velocity. A car is traveling along a road which is 30 degree west of north. Okay, which is 30 degree west of north. So let me explain it to you. So this is, let's say this is east, this is north, and this is west. And it is 30 degree west of north. So from north you have to draw 30 degree. So this is 30 degree. Hopefully you don't have any problem with this. This is saying 30 degree west of north. So from west go 30 degree towards, from north go 30 degree towards west. 30 degree west of north, while a bus, and this was, which is, okay, a man towards east. So man is moving towards east, something like this. So this is man, velocity of man, all right. A man towards east, a car is traveling towards, so this is velocity of car. While a bus is traveling another road which is 60 degrees south of west. So from west towards the south, 60 degree. So this is bus, and this is 60 degree. Hopefully everything's clear till here. Now they are saying find the angle between the velocity vector man and car. So first man and car. So this is 90 degree. This is, so for part A it's going to be from man and car, it's going to be 120 degree. Then car and bus. So this was 60 degree and this was also 60 degree. So for car and bus it is also 120 degree. Then for bus and man, so this is 30 degree and this is 90 degrees. Hopefully friends you can understand it. This is 120 degrees. So the answer is going to be option A. Right? It was an easy one just to find out the angle between the vectors. Now let's move to the vector law of addition. Vector law of addition, the basic law from which we will be able to understand how to add vectors, right? So vector law of addition basically means keep the vector such that the tail of one vector coincides with the, first let me explain it, then you can read it. This basically means that let's suppose that we have got two vector quantities, vector A and vector B, somewhere in this space. Make them, align them something like this, such that, so this is vector B, align them something like this that the head of vector A coincides with the vector B. What we are trying to do is we are trying to add them, vector A plus vector B. Alright. So the third side of this triangle is going to actually represent the sum of these two vectors. So this is the sum, let's say this is vector C. So that's how you are going to vector C over here. And if you want to find out the magnitude and the direction in which this vector C is, we are going to talk about that as well. But for now, this is going to be, let's say this is going to be angle alpha And that's how we can find it out. Right, we are going to find it out what alpha is. But this is the triangle law, and here are your notes. Keep vectors such that the tail of one vector coincides with the head of the other. Join the tail of first to head of the other by a line with an arrow at the head of the second. The new vector is the sum of the vectors, also called as resultant. Hopefully you have got it. This is what the law says. If you want to find out the direction, you can either find out the magnitude and direction. You can either use this law or you can use the parallelogram law. Both are basically the same thing, but I'm going to derive it in the parallelogram law topic, right? So let's not do it right now. Other than that, if you are going to actually closely see, if I'll actually give you another example for this, this is a note. Let's suppose that you have got a vector quantity A, right? And you have got a vector quantity B. These are the same vectors I am talking about, but now the vector C is drawn something like this. This is vector quantity C, but it can't be C. You are going to tell me, sir, it can't be vector C, because if vector C, this is vector C, then sir, this is going to be minus C. Absolutely correct. This is going to be vector minus C. You can call it another vector also. You can call it as a vector D. But what I am trying to say is, in this particular case, hopefully you will be able to understand, in this particular case, if I'll add these three vectors, that is vector A plus vector B and minus of vector C, my answer should be 0. This is absolutely correct, isn't it? I mean, it makes sense. That's what I have done over here as well. If you are going to add all of these three vectors, the answer should be 0, and then you can call this as some another vector, right? You can call this minus CS plus D. It's your wish, right? Similarly, we are going to use this as a polygon law of addition. What does polygon law of addition means? It means that, let's suppose that we have got like different vectors over here. We have got vector A, then we have got vector B. Please understand, till here I am adding in order, like head of A is joined with head of with tail of B. Then I have got like vector C, then vector D, then vector E, right? Now the thing is, if I'll join it something like this, the sum of all of these vectors is going to be 0. Is that correct? Can you please relate it with this triangle? That's why I have explained the polygon law to you. First we have done the same thing in law of triangle. Now we have done it in the nth sided polygon. Hopefully you can understand it, right? So if this is vector A, this is vector B, this is vector C, this is vector D, this is vector E, this is vector F. So the sum of all of these vectors are going to be vector A plus vector B plus vector C plus vector D plus vector E plus vector F. I am not writing minus F, by the way, is going to be 0. The value of vector F is going to be the negative times of sum of all of these vectors, right? So this is the thing that you must remember. After this, I've got notes for you. Same thing, whatever we have done, you have written it, I have written it for you as well. So you can find out all of these notes in the PW app. That's what I actually I forgot to explain it to you. Please log into the PW app. It's free. There's going to be no cost. Just you can get these notes from there as well, right? Moving on to the next one, that is parallelogram law of vector addition. This is actually something that I was talking about. In parallelogram law of vector addition, there is a difference. Now we are not going to join the vectors from tail to head. We are going to say that, let's suppose we have got a vector quantity A, and we have got another vector quantity. Now we are joining it with from tail to tail. So these are the two vector quantities, vector A, this is vector quantity B. The angle between these two vectors is theta, right? Let's say the angle between these two is theta. What we are trying to say is, let's draw a parallel vector to A, something like this. And this law says if you are going to draw a parallel vector to A, something like this, and you are going to draw a parallel vector B, something like this, not the other way around, then the diagonal of this parallelogram law is going to represent the sum of the vector, sum of these two vectors, and this is vector C. And this is the angle that we were talking about, that is alpha, right? And how we can do it? What we are going to do is, we are going to actually, this is also vector B, by the way. This is also vector B, right? So if you are going to draw a dotted line, something like this, and we are going to drop a perpendicular over here, then with the help of basic trigonometry, we are going to say that, okay, this angle is also theta. If this is B, then this component is this length is going to be B sine theta. This length is going to be B cos theta. We already know that this length is actually A. So it means that, if you can please understand, we have got a right angle triangle over here. This is the one of the point, this is the another point, and this is the point that I am talking about. In this right angle triangle, C is the hypotenuse, right? So the magnitude of C will be written as square of base, that means A plus B cos theta, square of this, plus square of B sine theta. So we are going to get A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Is it correct? Basic things, you might be knowing all of these things. Now out of this, B square cos square theta and B square sin square theta can be added up, and sin square theta plus cos square theta can be written as 1. And we are going to get our formula as the result. The magnitude will be the square root of A square plus B square plus 2AB cos theta. So this is the resultant formula. You must be knowing it. Please, if not, please remember it. One mostly used formula of physics, right? Most often used formula. What about the angle alpha? So for angle alpha, we are going to do a simple thing. We are going to write that tan alpha will be actually B sine theta upon A plus B cos theta. So this is the formula for alpha. Now that's what I was saying, that you can also manipulate this cos theta in many terms, right? If A and B are equal, what will happen? We are going to talk about almost every special formula over here. So after doing all of these things, the next thing that we have got over here is that subtraction of two vectors. What do we really mean by subtraction of two vectors? Now you have understood what do we really mean by addition of two vectors. Addition of two vectors can be done by vector law. If theoretically you want to do it by vector law. If you want to find out the magnitude and direction, I have explained it to you. Now if we want to actually find out the subtraction of two vectors, that means let's suppose we have got two vector quantities, vector A and B, and let's say they are quite similar to the previous case. Like for example, as this is vector A and this was vector B, right? This was vector B. Let's say this is vector A and this was vector B. So if you have noticed, the subtraction of vector would basically means we have to find vector A minus vector B. Is that correct? Right? That's what we need to know. Can I write it something like this? Vector A plus negative times of vector B. That means still I am talking about the addition of two vectors only, right? The only difference is now instead of writing B, I am going to write minus B as something like this. There is going to be no difference. So this is going to be minus B. And again, this is going to be parallel side of vector A and parallel side of vector B. So no difference as such, right? And then again the resultant is going to be something like this. This is going to be vector C, and this is going to be the alpha that, now let's say that this is beta. Is it all good? Quickly tell me in the chat box, quickly tell me in the comment section if you have understood it, right? So now everything is same, everything is going to remain same. So the only difference now you're going to see over here is that you can change the angle between A and B. So initially if the angle was theta, now the angle will be 180 minus theta. This is the only difference. And do you remember what cos 180 minus theta, what we can write cos 180 minus theta? Why I am talking about that? Because you are going to need that. So for cos 180 minus theta, if you remember it, I can rewrite this cos, this 180 as 2. I can actually write it as 4 pi by 2 minus theta. Is it correct? So this is even, so I'll have to write it as cos theta, and 180 minus theta, my friends. That means this is in second quadrant, so this is going to be minus cos theta. Hopefully everything is clear, right? So when you are going to put the values over here, this is going to be a square minus b square, fair enough, 2ab minus cos theta. You are going to write a minus sign over here, right? With this, let's move to some important points. See, the very first important point is that vector law is commutative. That means whether you do a plus b or you do b plus a, it basically means the same thing, right? I mean, whether you're finding out the magnitude or direction, everything will remain same. Vector law is also associative. It is very important. When you're going to talk about this formula, it will have the maximum value when this cos will have maximum value. Do you remember we have actually talked about all of these things, that when a particular function has got maximum value, don't worry about those maxima or minima thing. This is quite simple. It's not many things are changing over here. So we'll just say that okay, a is constant, b is constant, a is constant, b is constant. So if you want me to say that when this whole value will be maximum, it's quite simple, when this cos will be maximum, and cos is maximum at 0 degree. So I'll just put 0 degree. So if you have got like two vectors and you want to ask that, sir, at which angle they will have maximum resultant, at 0 degree they will have maximum resultant, and at 0 degree their resultant will be written with mod a plus mod b. Just add their magnitudes, right? Just add their magnitudes, that's going to be the resultant. Hopefully everything is clear. If you want to find out the minimum value, just ask yourself, when does cos gives minimum value? It is not 0, it is -1, right? So at 180 degree, that means when they are anti-parallel, and then the resultant will be written as mod a minus mod b. This is minus sign, my bad, this is minus sign. Alright, resultant of two vectors of unequal magnitudes can never be 0. Absolutely. If you have got like two unequal magnitude, if you have got two vectors which have got unequal magnitudes, then a minus b will never be 0, right? If vectors are of unequal magnitude, then the minimum 3 coplanar vectors are required for 0 resultant. I'll explain it. If you have any doubt in this one, I'll explain it. So let's suppose you have got a plane, something like this. Right? They are saying that if there are vectors of, if you have got if vectors of unequal magnitudes, then minimum 3 coplanar vectors are required. Very simple thing. If you have got one vector something like this, in the plane, You have got another vector something like this. Their resultant is going to be in this direction. Let's just suppose. So you need the third vector to cancel out this one. So the third vector will be something like this, so that we can cancel out these two. That's what they are saying, right? Moving on to some more important points. Now these points are very, very important. Even after we have finished this class, when you are going to write down these notes in your notebook, please go through them one by one, because if question from a vector will come, it might also come like a statement, whether this statement is true or not, right? Next is, as previously mentioned, the resultant of two vectors can have a value from a minus b to a plus b depending on the angle. Now what we are basically trying to say over here is that the range of resultant, this, let's say this is the resultant, so the range, the maximum value can be a plus b. Is that correct? The maximum value can be a plus b and the minimum value can be a minus b. So when they are anti-parallel, it would be a minus b or b minus a, and when they are parallel, it would be a plus b. So in this range, the resultant value, the magnitude of the resultant will lie. Minimum number of unequal coplanar vectors whose sum can be 0 is 3. Are you able to understand it? Even if you have got non-coplanar vectors, let me explain it to you. If you have got like 3 unequal coplanar, we have already done it. That was the previous. The resultant of 3 non-coplanar vectors can never be 0. This is what I was talking about. We have already discussed this statement in the previous slide. This has been already done. Done and dusted. Last one is important. Pause the video. Ask yourself, are you able to understand this thing or not? This is going to create your spatial sense. They are saying the resultant of 3 non-coplanar vectors can never be 0. It's actually quite true. The reason is, let's suppose that you have got a vector something like this. This is in this plane, right? This, and now obviously you're going to say, sir, these two can be called as in the same plane, that is this plane. But I'm going to talk about the third one. That's how we are going to talk about the 3 non-coplanar vectors, right? So let's understand something like this. Let's suppose we have got one vector on this plane. We have got another vector over here, right? Got it? And then we have got another vector something like this going downside. Something like this. So the resultant of these 3 vectors are never going to be 0. 3. You must need one more to actually make the sum to be equals to 0. And think about it in the spatial sense, right? Just pick some couple of pens, draw x-axis, y-axis, z-axis. You have got 3 planes. Do it by yourself. Think about it. Now we are going to talk about the next point, which is, we have already talked about all of these things. These are for your notes. Everything is right. Resultant, we have talked about like almost everything over here. All right. What about this? Resultant of 2 vectors of equal magnitude will be at their bisector. A very important thing, right? So if you have got like 2 vectors of equal magnitude, and let's say it is something like this. This angle is, let's suppose this angle is 60 degree or theta degree. And this is vector A, and this is also vector A, or at least the magnitude is exactly equals to vector A, right? I can't write vector A, by the way, that would be wrong. So I'm going to write this is vector B, whose magnitude is actually equals to vector A. I can do that, right? So in this case, the resultant will be drawn something like this, and this angle will be 30 theta by 2. So if this is going to be theta by 2 if the angle was theta. That's what they are saying. Quite basic thing. And if let's say if any of the vector is greater, then the resultant will bend towards that thing, right? So if let's suppose A is greater than B, then these two, out of these two vectors, if I am going to say that this is, let's say this is alpha, let's say this angle is alpha and this angle is beta. So in that case, beta will be greater than alpha because it will bend towards A. Hopefully you are able to understand it, right? So after this, this is the diagram that we were talking about. If they are of the same magnitude, then theta by 2, and the resultant will be written something like this. Now what is this? I'll explain it to you. So this is nothing but the resultant was the magnitude could be written as a square, because they have written as a square plus 2a square cos theta. Is that correct? So can I take out a common, and in that case we'll be left with this is 2, this is 2. So I'll write 2 and this will be 1 plus cos theta. Hopefully everything is clear till here, right? Now if you remember, we talked about an identity which said that cos square x will be written as 1 plus cos 2x divided by 2. Is that correct? Right? So that means 1 plus, from this we can imply that 1 plus cos theta, 1 plus cos theta can be written as 2 times of cos square theta by 2. Is that clear? Does it make sense? This was the original identity. If here we have got x and here we have got 2x, then if this is theta, can I write it as theta by 2? So I'll do that, I'll do the same thing. So I've got a over here and I've got 2, instead of 1 plus cos theta, I'm going to write 2 cos square theta by 2. So I'll be left with 2. I can actually club 2 and cos square theta. So this is going to be 2a cos theta by 2. That's what we have got over here. 2a cos theta by 2. Very, very important. Hopefully you can clearly see it, right? So this is actually an important thing. It will save a lot of time. Right, quickly, if you have got two vector quantities equal in magnitude, direction is angle between them is given, just quickly write down the formula. Apply the formula 2a cos theta by 2. That's it, right? So friends, after this, hopefully you are able to understand it. After this, we are being left with resolution of vectors, then product of vectors. In resolution of vectors, there are many things. And instead of just drawing resolution of vectors, what I'll do is I'll actually use some real physics problems from Newton laws of motion or from, let's say, from kinematics. I'm going to do that. So let's start. Let's suppose that you have got a Cartesian plane, something like this. And you have got vector quantity A over here. Okay. And this is the angle theta, right? Now, before moving to resolution of vectors, I would also like you to actually explain how we represent a vector mathematically. We already understood that how we represent a vector. Now, what we are going to do is we are going to actually say that a vector quantity has got two things. We know that it has got magnitude and it has direction. We know that magnitude is defined by a numerical value. What about direction? So for direction, we are going to use a concept of unit vectors. So for direction, we are going to use a concept of unit vectors. What do you mean by unit vectors? So again, their name explains themselves. Unit basically means their magnitude is 1. So if you are going to attach a unit vector with another vector, all you are trying to do is you are just saying that this unit vector is only there for representing the direction. Got it? So we have got mainly, you can have many unit vectors, but along this Cartesian plane, we have got 3 unit vectors. Like for example, as I cap, j cap, minus I cap, and minus j cap, and then you have got like 2 vectors for, like you have got, let's say this is z axis. So this is k cap and minus k cap, the counterpart of this, right? So if you want to actually find the component of this A vector, let's say that we are just trying to find the component of this along the I cap and j cap. So I'm going to write, this is the horizontal component, this is going to be A cos theta, this is going to be the vertical component, this is going to be A sin theta. Now please understand, this A cos theta and A sin theta, they never can be greater than A, of course, right? Because sin theta and cos theta can never be greater than 1. This is, I mean, these types of question may come in NEET, right? So these are known as the components. This is known as the horizontal component. This is known as vertical component. Alright, so they can never be greater than A. So the representation of A vector can be such that vector A will be A cos theta. So this is the magnitude times the direction, that is I cap, plus A sin theta, this is the magnitude times the direction j cap. So this is nothing but we have written the A vector as the sum of 2 vectors. And if you are going to add them, so if you just want to see how this works, so this works something like this. So this is an individual 2 vectors. Just think it like that. So the addition of these 2 vectors is going to be A square cos square theta plus A square sin square theta. Can you please tell me what is the angle between these 2 vectors? So 2 A cos theta, A sin theta, cos 90. Hopefully you are getting it. Why I am not writing everything? Because anyway it's going to be 0, right? So anyway this is going to be 0, so let's not write it. So this is going to be A square plus A square, that is 2A square, that is A. That's it. So no need to write all of these things, right? It will come A obviously. I mean, out of A only we have made these 2 components. So after this, what we are going to do is we are going to also say that this vector, any vector quantity vector A will be written as magnitude of vector A times unit vector of A. This is very important, because after this, if you want to find out the unit vector of unit vector, all you need to do is you need to actually divide a vector with its magnitude. So you are going to get a unit vector. This is an important thing. Example, I am going to give you an example. Let's say that we have got a vector A, which is actually 3I cap plus 2j cap plus k cap, and I want you to find out the unit vector along this. Or let me write something like this. Write a vector of magnitude 10 parallel to A. Can you do it? Can you do it? Tell me. Vector has got 2 things. One is magnitude, another is the direction. I have explained both the things. Magnitude is 10, it is parallel to A. Sir, but what do you really mean by parallel to A? It means that the direction of the vector that we want to write is same as vector A. Now how to actually take the direction from vector A? All you need to do is you need to write down the unit vector. Hopefully you are getting it. So the unit vector will be written as vector A divided by magnitude of vector A. So vector A is 3 I cap plus 2 j cap plus k cap divided by, my friends, magnitude will be written as square of 3, square of 2, square of 1. That means this is going to be root 14. So this is going to be 3 by root 14 I cap, or what you can simply do is 1 by root 14 3 I cap plus 2 j cap plus k cap, right? Now the required vector will be is going to be simply vector is magnitude plus direction. Magnitude is 10. What about direction? Direction is 1 upon root 14 times 3 I cap plus 2 j cap plus k cap. It might not look good to you. The answer might not look presentable, but this is a vector quantity. Just now multiply 10 by root 14 to each one of them. You're going to get every component, x component, y component, z component. Is that correct? Clear? These are some of the basic things, but basic things are more than sufficient to clear your concepts. Other than this, you're not going to face very difficult questions from vectors, right? Because we are not learning vectors in mathematics. Now, when I was talking about the resolution of vectors, sometimes what will happen, that you have got something like this. Let's say this is an inclined plane and we have got an object over here, object kept on the inclined plane, something like this. And we have to draw the free body diagram of this, right? So hopefully every one of you knows what free body diagram means. And also this angle is theta. So we know that mg will be drawn something like this. Now often what we try to do is we try to write down the vectors along some of the specific lines. Like in this one, usually the specific lines are the x-axis and y-axis. So we usually resolve, that's what the word is, we usually resolve all the vector quantities along x-axis and y-axis. But sometimes we don't do it. It depends on our comfort. For this question, it is actually easy for us to actually resolve the component along this surface, along the surface of the inclined plane, right? And the perpendicular to this inclined plane, something like this. So that's what we are going to do. So if this is angle theta, this is going to be angle theta, right? Obviously, I mean, if this is angle theta, this is going to be 90 minus theta, this is going to be angle theta. So this mg will be, wherever the angle is, this is going to be mg cos theta and this is going to be mg sin theta. Please remember that if you have got an angle over here, on this side you will have the cos component. I am not talking about horizontal or vertical. Wherever I am labeling the angle, on that side I am going to write the cos. That's it. No more confusion, right? If you are talking about, if you are saying, no sir, I am marking angle over here, okay, fine, this is 90 minus theta. So this is going to be mg cos 90 minus theta. Cos 90 minus theta is sin theta. Sin 90 minus theta is cos theta, right? So this is it. Other than this, you can have different diagrams. Like for example, is you have got a question for like I think that will be all. You have got the drill. If you have some questions like this, that you have got different vector quantities, vector A, vector B and vector C, all you need to do is you need to just draw their, just resolve their components to along the x-axis and y-axis and then just add them or subtract them. That's it, right? So with this, friends, I'll give you couple of questions in homework. Like for example is this one. If A is this, B is this, calculate the direction of A plus B. Easy, not that difficult, right? It's an easy question. You can do it. Very easy. Homework. This is from slide 92. So we have done till 92 slide. Is it good now? Hopefully I can give some homework to you. The unit vector parallel to resultant of the vectors is, can you do it? It's quite easy, right? All you have to do is, my friends, you just have to find out the vector a plus b, and vector a plus b will be, it can be calculated with quite ease. 4 minus 1, 3 I cap, 3 plus 3, 6 j cap, 6 minus 8 minus 2 k cap. And then the unit vector of this, so unit vector of this is going to be a plus b, and the unit vector of this will be this vector quantity divided by the magnitude of this vector quantity. One by 7, hopefully this is, yeah, 3 I cap plus 6 j cap minus 2 k cap. Although I was thinking to give you this question as an homework as well, but okay. So I think it's the first one, right? Yeah, first one. One more question, but now please do it this in homework, right? This is from slide 94. Write down your answer in the comment section. Discuss it. Discuss means let's all discuss, whoever is going to watch this video, and I'll also share the answer, right? Great. Then let's talk about now multiplication of two vectors. Now we have talked about addition, we have talked about subtraction. When we are going to talk about multiplication of two vector quantities, there is actually two types of multiplication that is possible. One is scalar multiplication, scalar product, also known as dot product, why it is known as scalar and why it is known as dot product, it is also quite easy to understand. The reason is that if you have got two vector quantities, vector A and vector B, so you are going to put a dot between them just to show that you are talking about scalar product. And the reason why we are calling it as a dot product is the output of this thing is going to be a scalar quantity. What that formula is going to be, we are going to talk about it. Let's not rush. Just because we are about to complete it, let's not rush. The answer is that the resultant, the product of these two vector quantities is going to be a scalar quantity. Like for example as work done, right? So for work done, it is actually the dot product of force and displacement. Force and displacement both are vector quantities, but work done is a scalar quantity. The next type of multiplication is known as vector product or cross product. So in this one, A cross B will be written as mod A, sorry, again I am not going to write the formula, but I am going to just say that this is going to be a vector quantity. We are going to talk about the formulas, but let's wait, right? After this, the first type of product, as you already know, is actually a scalar product. So when we are going to talk about scalar product or dot product, we are going to say that A dot B is written as Now I am talking about the formula. Magnitude of A times magnitude of B times cos theta. And theta is the angle between A and B. And there is no direction on the right hand side of the equation, right? So this is it. Now there is also some more things over here. Let's suppose that you are going to talk about like I cap, this is I cap, this is J cap, this is K cap. So vectors which are perpendicular to each other, their dot product is always going to be 0. Please understand. So I dot J is going to be 0. The reason is I am writing it down here for you. So please make a note of it. I am going to write mod I, mod J, both of them are 1. Cos of angle between them is 90 degree. Hopefully you can see it. So this is going to be 0. Similarly, J dot I is going to be 0. I dot K is going to be 0. J dot K is going to be 0. So this is very important. Other than that, parallel vectors, if you are going to multiply the dot product with the parallel vectors or parallel unit vectors, for example, as I dot I is going to be 1. Just do it by yourself. J dot J is going to be 1. K cap dot K cap is going to be 1. Right? So if someone says that we have got two vector quantities, vector A is 2I cap plus 3J cap plus K cap, and we have got vector B as 2I cap plus 2J cap plus 2K cap. Find out the angle between these two vectors. So you can use the dot product over here to find out the angle, right? How you are going to find it out? See, I know that how to find A dot B. Now I know. I'll just multiply them. Like 2I cap dot 2I cap, it's going to be 4. Plus, I don't need to multiply 2I cap with these ones. Why? Because if I multiply 2I cap with J cap, 0. If I multiply 2I cap with K cap, it will become 0. These are perpendicular vectors. So I just have to multiply I cap with I cap, J cap with J cap. So again, this will be 6 and this one is going to be 2. Equals to, this is also equals to the mod value of this A that we know. You can calculate it, mod value of B and cos theta. So you can find out the cos theta from here. So what I am trying to say is, if you want to find out the value of cos theta, all you can do is you can write cos theta equals to A dot B divided by mod A mod B. And do you remember something like this? Vector A divided by mod A can be written as A cap. B divided by mod B can be written as B caps. Also write that thing down, right? So if vectors are perpendicular, dot product is going to be 0. Please remember this thing. You are going to use it quite often, huh? If this is the case, then P dot Q is 0. Alright, moving on to the next topic, that is the vector product. In scalar product, I think we have almost done everything, nothing much is left. You can also talk about like the component of A on B, but it's fine. You can understand that thing by yourself. When we are going to talk about vector product or cross product, we are going to say, in this case, A cross B is actually equals to mod A mod B sine theta. So till here, still it is we are just talking about magnitude, right? The only difference is in the previous case, in the scalar product, it was cos theta, now it is sine theta. But the difference is, now we are going to also talk about a unit vector, n cap. This is the important thing. What we are trying to say is that now the vector product of two vectors is also a vector quantity, and the direction will be given something like this. See, if this is a plane on which A and B are, and A and B are also always going to be in a same plane, right? So this is a vector A, this is vector B, and this is vector, this is the angle between them. So the direction will be solved using this n cap, that is the unit vector. It will be found out using right hand rule, not the right hand rule that you know from grade 10th. Right hand rule for cross product. The rule is something like this. I'll explain it to you. Keep your palm perpendicular to the plane on which these vectors are. So these are on this plane, on this digital board, right? So I'll keep my palm in the perpendicular direction. Keep your fingers along the direction of the first vector, that is A. Stretch the fingers something like this. So it could be like this or it could be like this. I don't know yet, right? So let's say that it is something like this. Now move your fingers in the direction of acute angle, along the direction of acute angle, such that your fingers touches the vector B. So that's why I was saying that it couldn't be the other one, right? If this is the case, then this is going to be the reflex angle. I have to find out the acute angle. So this is the acute angle, so thumb is pointing outwards. This is the direction of n cap, right? So over here I am going to draw the direction of n cap something like this. So this means that dot product, the difference between the dot product and cross product is, first of all let me write it, this is n cap. The difference is, the dot product was commutative because we were just talking about the magnitude. This is another important point. Dot product is commutative. A dot B is exactly equals to B dot A. Because we are just dealing with magnitudes. But now we can't say something like this. A cross B is not at all equals to B cross A. A cross B is not at all equals to B cross A, and the reason is n cap. Hopefully you can see this pen as well, right? This is very important, that this is not commutative. Although the magnitudes will be same. Magnitudes will be same, right? Now to find out the direction and the, what we can say, basically we are being left with the direction of vector quantities of the vector product. It is of, we can find it using two ways. First way is, and I'll try to explain it using both the ways. Let's say this is x-axis, this is y-axis, and this is z-axis. Now obviously over here, similar to the previous case, if you are going to talk about the parallel vectors like I cross I, that will be 0 because sine 0 is 0. J cross J, that will be 0. K cross K, that will be 0. So remember this thing, that parallel, the cross product of parallel vectors is 0. Cross product or vector product of parallel vectors is 0, right? But if you are going to talk about I cross J, let's discuss. I cross J using the same rule. Keep your fingers along I, curl to meet J, So it would be something like this. Where is your thumb pointing? Towards K. So I cross J is K. Let's do it again. If you are sitting on a chair, something like this, let's suppose you're watching me and you're sitting, you must be sitting something like this. Here must be a screen or anything. So just assume that over here, this is your y-axis, right? This is your y-axis, this is your x-axis. So I, and this is your positive z-axis. So I mean, I don't know how you're going to draw it. I always assume it something like this, right? So if this is your I-axis, this is your z-axis, I am putting I along, fingers along I, moving along y, this is my z, right? Similarly, if I am going to talk about I cross K, where is my I? My I is in this direction. Where is K? In this direction. So I have to move something like this. Fingers along I, move something like this. So this is minus J, minus J. Now you can do it, you can play with it. I'll also share a trick for this. The trick is just write I, J and K in a circular manner. So I cross J will give you K, J cross K will give you I in the clockwise manner, and if you will go anti-clockwise, you will put a negative sign. So I cross K will give you minus J. Now you can do it any way which you want, right? The last method for this one is that if you have got two vector quantities, for example, you have got vector A is A1 I cap plus B1 J cap plus C1 K cap, and vector B is A2 I cap plus B2 J cap plus C2 K cap, right? So if this is the thing, so draw something which is called as matrix. So matrix is nothing but an array of numbers. It's a way of putting numbers, right? So in the first, and we have got certain rows. So like we have got like 3 rows. So this is row 1, row 2 and row 3, and we have got columns, column 1, column 2, column 3. Usually we don't mark it something like this. I'm just explaining it to you. And over here we have got something like I cap, J cap and K cap. And for this one we have got A1, just put the numbers, right? Now you have got the idea, B1, C1 and A2, B2, C2. This is going to give you the magnitude as well as the direction of A cross B. How? I'll tell you. We say that we have to actually find out the determinant value of this matrix. How we are going to do it? We are going to actually expand this. We are going to expand this determinant, this matrix about the first row. This is the first row, right? And amongst this first row, we have got this element is at 1, 1 position. What do you mean 1, 1 position? First row, first column. This one is at 1, 2. First row, second column. This one is 1, 3. First row, third column. Whenever the sum of these two comes out to be even, you open with a positive sign. Odd, negative sign. Even, positive sign. Might look very erratic, very absurd, but it will work every time, and this is actually quite efficient other than doing something like this. Although those things have another advantage, like for example is when you are going to talk about whenever you are going to talk about torque, cross product, whether it is torque or anything, the right hand rule will be the most efficient way. But right now we have to find it out, like we have to find out multiple multiplication. So instead of doing like that, you can also solve it in this way. How to do it? I'll explain it. So the expansion will be something like this, A cross B. So let's start with the I cap and put a plus sign, reason I have told you, right? apply some brackets, delete this column, hide this row, hide this column in which I cap lies. All you will be left with is this thing, right? Now multiply B1 with C2, so you will get B1 C2, put a negative sign, multiply C1 B2. Now do the same thing. You have to just do it twice. Write J cap but with a negative sign, minus J cap. Again hide the row in which J cap is, hide the column in which J cap is. You will be left with A1 C2 minus C1 A2 plus K cap A1 B2 minus B1 A2. That's it. This is how you're going to get the direction as well as magnitude instantly. If you want to find out the magnitude, just put a square root, square them, add them, you're going to get the magnitude also, right? So with this, friends, we have also completed the vector product. Vector product is not commutative. Last few questions in homework, my friends. Solve it down by yourself. Hopefully you can do it. Question on slide 99 is for you. Vector product. F1 is along positive x-axis. You can do it. I have full confidence. And the next question is, just a second. The next question is this one. Only 2 questions in more homework. In homework, F and I have given you R and F. You have to find out the torque. So for your practice, right? I'm not doing it. It's for your practice. That will be all for today's class, right? So thank you so much. Please remember that you are going to get the notes on PW app, and we are going to come up with almost every other chapter on this channel. So stay tuned. Pay attention that we are going to come up with these classes, and it's going to be very beneficial for you. And if you want any other help, if you have any other suggestion, write down that in the comment section, right? So thank you so much. Signing off. Take care. Goodbye.